idea about first how are we going to proceed for the whole session, and how many sessions we'll be conducting, how many.
In case anyone is speaking, I am unable to hear.
Okay. It, mm, is my voice now? Is it fine now? I hope from my side it's fine.
Yeah, it's clear.
It's clear, right? Okay. Thank you. Thanks everyone for coming up. Okay. Is my screen visible to you guys?
Yes, sir.
Okay.
Yes, sir.
Hmm. Thanks. So I'll just give you an idea about how are we going to proceed for the next 3 or 4 months, like 12 weeks of content, and how are we going to deal with that. So I'll just write it down. So some of the things you might already be knowing, but yeah, even though I'll just reiterate it regarding the number of sessions that we are going to conduct. The first thing. Hmm. So the number of sessions that we are going to conduct per week, okay? So we'll be having 3 sessions in the starting 4 weeks. So we'll be having 3 sessions per week, and the timing will be from 8 to 10. Okay, so that if somebody is a working professional, or somebody is having other courses also, he might or she might be free during that time to attend the sessions. Okay. Apart from this, this are the instructor session that I was talking about. You'll be having some TA session also. Those session, the TA session, the timing will be from 4 to 6. Okay. You can check the calendar for the dates. For the day, mostly the instructor session will be happening on Saturday, Sunday, and Tuesday. Okay, you can just check it once. Okay, and for the TA session, you can just check the calendar. What's the timing? Like the timing is correct. You can check the day. Okay.
Sir, is this
Mm.
instructor session or something else?
Yeah, this is an instructor session only.
Yes, sir. So that means you will means teachers whole content of week one today.
Yeah,
Whole
yeah,
day.
I'll be going through the whole content of week 1.
Okay, sir. Thank you.
Thanks. Okay. So this is for the number of sessions that will be happening per week. Uh, then the second thing is regarding the quiz. So I hope you already know that your quiz is on mid March. Okay, 15th of March. I hope your
15th
first
March.
quiz.
Yes.
Yeah. So we'll be having 3 quizzes. Quiz 1, quiz 2, and then the intern. Okay. All of 50 marks. This both will be of 1 hour session, 1 hour paper, and this will be of 1.5 hour. Okay, the content for quiz 1 will be from week 1 to 4. The second one will be from week 5 to week 8, and the third one will be week like 1 to 11. But most of the weightage will be from week 9 to 11. Okay. In maths, you just have 11 week of content instead of 12 that you have in stats or in other courses like CT. Okay. So here you just have a 11 week of content. I hope this is also
Excuse me.
clear. Yeah.
Quiz 1 and qualifiers exam are the same, or there is distinction
Yeah,
between them?
both are same. If somebody who is the foundation student who has already written the qualifier, for them that exam will work as a quiz 1, and for somebody who didn't got the admission till now, who is just writing the qualifier, that will work as a qualifier. Okay, the paper will be same.
After proceeding this qualifiers exam, so we are supposed to be giving like quiz 2, or we have to repeat quiz 1 again?
No, no. If you want to continue, you can write quiz 2 and then intern. If somebody doesn't want to continue, maybe there's an option that you can go for the next term also. Like there are some conditions. Then if somebody is just passing the qualifier this time and doesn't want to continue, maybe in the future he wants to continue, then he can do it. If somebody wants to continue now itself, you can go proceed with the quiz 2 and intern. Okay. Is it clear?
Yeah, it's clear.
Okay.
Yes, sir.
Yeah. Regarding all the solutions and all, like graded assignment solutions. So the third thing is the graded assignment solutions and practice assignment solutions. After every week, like as let's for example for week 1, the deadline is on 18th of Feb. Okay, so 19th of Feb your solutions will be uploaded. Okay, so graded assignment solution plus practice assignment solution, everything will be uploaded on the portal. Okay, if you'll go to the portal, there is something called supplementary content. There in the supplementary content you'll see that graded assignment solution and practice assignment solution, that will be uploaded. Okay, if it's not uploaded, you can just let us know. We'll be trying to upload. We'll try to upload it just the day after the deadline. Okay, so that if you are doing some mistakes or something, you can go through it and you can get an idea about that. Okay, and yeah, regarding graded assignment, one more thing. Yeah, and I hope if you have not gone through the grading policy for this term, okay, you already know that they're in the quiz paper, right? The quiz 1, quiz 2, and in term. Okay, you'll be getting minimum of 10% of the questions in the in exam, like quiz 1 and quiz 2 papers. 10% of the questions will be exactly same from your graded assignments itself. Okay, so if somebody is practicing graded assignments nicely, minimum of 10% of the questions will be exactly same without changing any values, anything. Okay, so those, if you are continuing and if you are solving each and every problem of the graded assignment, you'll get benefit in the quizzes also. Clear? And yeah, and graded assignments also you have to submit it every week. I hope that you are already knowing, so those are already there. Okay, so so these are the some of the important things that I want to clarify in the starting itself. If you have anything, then you can just let me know, or else we'll start continuing the session. We'll start discussing the content of week 1. Anybody has anything?
Yeah, I have one question.
Yeah.
Yeah, actually, in case of some busy work or something, if we may miss a 1 week assignment, can I continue that? Can I fill it in next week, or it we cannot do that?
You can't submit that particular, like let's for example the deadline is 18th, right? And if you are not able to submit for week 1, you can't submit for week 1, but yeah, you can submit for the other weeks. Like there's a
Okay.
criteria that you have to submit, like as maximum as possible. Like out of 11, there is a criteria that you have to submit some 7 or 8. Best
Oh,
7 or
okay.
8 will be considered for
We have
your
some factor of safety. Okay.
yeah. If somebody is missing 1 2, that's not an issue. Yeah.
Okay. Okay. Thank you.
Sir,
Sir, could
Yeah.
you
excuse
explain the
yeah.
passing T-score distribution of marks?
Oh, T-score distribution, like there is some two formulas might be given there. Okay, there's formula like there might be formula. If somebody can just write it the formula, I can explain you. But I can just give you a brief idea about the formula. So there might be two formulas. Okay. Okay, one formula, like I don't remember the exact formula because for every courses that I take, there are some different formulas. So I can just give you an idea about. You can just interpret it
Yes,
in
that's
that same way.
fine.
Okay. Okay. So let's for example, there is some 25%. If it is written something like that, quiz 1, okay, and then 25% of quiz 2, and then something like point. So the two formulas might be there, and 50% of the final quiz. Okay, the intern. So it just means that 25% of the quiz 1 marks will be added to your final score, and 25% of the second quiz, and then 50% of the intern. Okay, if you are writing all three. If somebody is not writing all three, somebody, let's for example, misses one of the two quizzes, you can't miss the intern. If somebody has some, like maybe because of some emergency or something, somebody is missing quiz 1 or quiz 2, there is another formula also where your marks will get reduced to 90 marks only. So you can get a maximum of 90 marks. Okay, if you are missing one of the two. Okay, if you are writing all three, your marks, the whole marks will be 100. But if you are missing one of the two quizzes, your whole maximum marks that you can get is 90. Okay, and apart from that, there is some bonus marks also. Bonus marks of some 5 marks or something that you can check in the grading policy. Okay, and out of
And sir,
this,
what about the graded assignments?
yeah, graded assignment, I told you, right? From the graded, there is nothing directly will be added to your T score, the total score in graded assignment. But yeah, that we are assuming that
Okay.
10% of the questions will be from graded assignment. Minimum of 10% of the questions in the quiz paper will be from graded assignment. That we are assuming. Okay, so
For
Okay, sir.
all the exam or
graded
just for the quiz
assignment
one?
solution. And one more thing, graded assignment you have to submit. Okay, there's a criteria. Okay, if you are not submitting the graded assignment, you will not be eligible. So graded assignment now is the eligibility test for your writing, whether you will be able to write the quizzes or not. Okay, so you have to submit it. It's not like you'll just miss it. If you are missing it, you'll not be eligible to write the quiz paper itself. Okay, so you'll have to write it. Okay.
Hello,
Okay,
sir.
Yes, sir.
yeah.
I have one doubt.
Hello.
Like in case of if I miss any video, okay, some of the video I see that is uploaded or like pasted in the like calendar, but others like videos are not found anywhere. Like suppose today there was a match session which I couldn't join. So from 4 to 6, but I could not find any link or any recording of the session. So where can I find those things, recordings and
Okay,
all?
for the TA sessions, okay, for the TA session, the TA will share you one Google Sheet, okay, that will contain all his sessions, okay. The recording he will do recording of each sessions, and then there will be a link, okay, that you can get it tomorrow in the next session. I'll ask the TA to share you the Google Sheet. That Google Sheet contains all the link for all the recordings, okay. So from there you can refer. The session that we are conducting right now, all the session that will happen from 8 to 10 p.m, right? Those
Yeah.
all
Hello, sir.
sessions,
I have a question.
just give me a second. So from 8 to 10 that will be conducting, okay. Those session will be there on the IIT Madras YouTube channel itself. So from there you can access. Even though if you don't want to access from there, you are getting difficulty. In the same sheet, yeah, in the same sheet we'll be putting the YouTube link, okay, the week wise all the links. So from that sheet also you can access this session also. Okay, the next question, somebody is asking
Yeah,
something.
Yeah, I
like
believe that the
the sheet. Where can I
today.
find the
Hello.
sheet? Like,
Hello, sir. I have a
Yeah,
question.
yeah, if one by one you
Sir,
can ask
after
it.
our
Yeah, go ahead.
sir, let's yes, sir. I have a question that after our quiz one, we can see our marks on the portal. So these marks are out of 100 or out of 50, sir? That is my question.
Okay, even though that is from 50 or 100, that's not going to make any difference, because in the end 25% of that marks will be like added to the quizzes. Okay, so even though that is of
Okay, sir.
100 or
But how we can know the how our score is in our quizzes?
on the dashboard it will be shown, okay, out of 100 it will be shown, okay. But that's not,
Yes,
even though
sir.
that is from 20 marks, that's not. So let's, for example, you are getting 95% of the marks, right? So it can be
Yes, sir.
shown as 95% out of 100, right? Or in 45
Okay,
marks,
sir.
sorry, in 50 marks it will be shown as 47.5. So that's not going to make any difference, okay, at the end.
Yeah, yes, sir. Thank you very much, sir.
yes,
Thanks.
sir. The sheet the TA is supposed to share. It will be shared on the portal.
Yeah,
Like,
TA will share you the seat, Google Sheet, in the next session, okay.
okay.
Yeah,
Hello.
hello, sir. I believe today TA had shared the Google Sheet. Hello.
Okay, yeah, go ahead.
Yeah, today TA had shared the Google Sheet, sir. Perhaps it will work, right?
Yeah, it will work.
Oh, thank you.
Yeah, can you share in the chat? I don't
Okay,
appreciate.
somebody who
Sure,
got
sure. I
this,
will,
yeah,
sure. I
who
will
got
share
the
you.
seat, he can just share it. Okay, so
Sure.
the exact the T score for the maths is something like max of 0.6 times. This is for the final quiz, and then you have 0.3% of maximum of quiz 1 and quiz 2. Okay, this is the first formula, and the second formula is 45% of the income plus 25% of quiz 1 plus 30% of quiz 2. Okay, so you can see that if you're writing quiz 1, quiz 2 and final, all three, your marks will be calculated out of 100. And if you are missing out one of the two quizzes, okay, then your marks will be calculated out of 90. And out of this two formula, whichever best that you will be getting, that will be your final score. Okay, so there's no marks of assignment this time, but only eligibility criteria. You have to submit it something 5 out of 7 in the starting, 5 out of 7 to get to write the quiz to our intern. Okay, is
Sir, I
this
have a
clear?
doubt regarding the graded assignment. Like you have said, 10% of the question will be from graded assignment. So it will be in the all exam, like all quizzes, or in the like quiz one and quiz two only.
In all quizzes, quiz 1, quiz 2, interim, all.
Okay. Yeah. Thank you.
Okay. So I
Sir,
hope
is,
now this, yeah, go ahead.
sir, is this session for data science student or a student also?
This is for data science. Yeah.
Thank you, sir.
So, sir, it's better if we attempt both the quizzes, right?
Yeah. It's better to attempt both the quizzes.
Okay, sir.
Okay. Can we proceed with the content now? If everything, LOPS, operational doubt
sir.
has been clarified. Okay.
Sir,
Okay, then
excuse
I'll.
me, sir. Sir, I
Hmm.
have to ask that is there an issue with my calendar or is there going to be live session of stats and CT as well?
When? Now.
No, whenever. Like I can't see any live session of
Okay, so
stats and
you'll
CT.
have to add the calendar in your Google Calendar. So what you can do is go to the course page, and if you go to the course page, there is something called. Mm, if you'll open your portal, right?
Okay.
On the portal, I guess there might be something called the calendar link or something. If you'll click there, that
Okay.
will get added to your own calendar. All the okay,
Okay. Thank
so
you,
that
sir.
you can try it out. Huh? If
Sir,
that was yeah.
sir, in the calendar, I
Sir, I
have
have one
added
question.
Yeah, in the calendar.
Hello.
After that,
in
you
the
can
ca
go.
in the calendar, I have added every every subject's calendar link, and there are only there are only TA sessions for statistics and CT, and only read with us for English. There are no instructor sessions for them.
Okay.
Instructor sessions
Maybe.
are only for maths.
Okay. Okay. I can see for which course you're talking about. Statistic.
Statistics and computational thinking.
Statistic. You can see right. I can see the sessions. Tomorrow you have 6 to 8, right? That is instructor session only. Tomorrow on 17th you have 6 to 8. That is also instructor session.
Sorry, for me, I didn't receive any statistics related invitation actually.
No, you will not receive any invitation. You have to go to the portal.
Actually, there is no option seen on the portal for us to add that to a calendar or to get the live session, to get to the live session.
Is it? Okay.
The calendar.
Sir,
Yeah.
In calendar, it's
uh,
clearly visible.
is this only a revision session or can we also ask doubts related to the...
Yeah, you can ask doubts, but once I'll go through the content and then you can ask the doubt.
Please,
See,
sir.
on the
Okay, sure.
portal, you can see that there is something, some link will be given where you can add the calendar. Okay. For maths, I can give you. For statistic or for other courses, what you can do now, whenever the session starts, when next session will happen, right? Ask the person, uh, see or he will maybe share the calendar link that you can add it. Okay.
Should I share my calendar link in the group? I have for all.
Yeah, there
My
might be for
calendar
sure because
users.
other people are able to do so. How can like some people are not able
It's
to?
already given in our dashboard
Yeah,
added.
it is there on the dashboard.
Yeah,
Okay,
yes, sir.
so okay, I hope that is clear. So can we start now? I hope you are already
Please, sir,
passed.
please.
Yes, sir. Please start. Don't waste time.
Okay, it's fine, it's fine. We can have the meeting. Okay, so the first week, why my voice is repeating? Hmm. Okay, you can everyone please mute yourself so that will be easier for me and other people. Okay, in between, whenever you have a doubt, you can just let me know. That's not a point, but yeah. So in week one, right? It's a pretty simple week. Most of you are already know most of the content, but I'll just go a bit faster wherever like these are very basic concepts. So that's why I'll be
Sir,
going very.
actually, I have not watched Steve Week 1 content, so
Okay,
that's
that's
why.
not a problem. If I will just listen to this session, that will suffice. Okay.
Yes, sir.
Okay. So in the starting, we have just started with the number system. Okay, because these are some of the very basic and but important things that you must be knowing. So we started with the natural number. The only thing that should be having in your mind is whenever you're talking about the natural number, this is just whatever number that you use for the counting, right, from zero, okay, that those are the natural number. Maybe in the childhood you would have learned there is something called whole number also. So whole itself, if somebody knows, whole means pura, right? So whole, whatever you were studying in the childhood, there it used to be have 0, 1, 2, and then till infinite. A natural number that you have studied in childhood that used to start from 1, right? But here you don't have to read anything about the whole number. There's only natural number, and that natural number contains 0. And that is important because from now onwards, whenever you'll be asked regarding the natural number, or any question that has been given where you have to count the number of natural number or anything, it's not about counting. Nobody is going to ask you the counting. But yeah, you should be having in your mind that whenever you are reading, natural number from now onwards for you guys contains 0. Okay, because whenever you'll be learning the Python and all, everywhere, okay, the natural number contains 0. So there should not be, many books consider it, many doesn't consider it. But yeah, for ours, from now onwards, whenever in the whole data science will be learning that 0 will be included in the natural number, so you don't have to go
So
here and there. Okay,
does it mean that natural numbers are equal to whole number in data science?
you can consider it, but yeah, this all depends on how people consider it. Many of the, I told you, right, many of the books our prof consider it, and then from now onwards you have to consider it. Okay, so
Okay,
you
sir.
have to consider 0. There's nothing called, we have not discussed anything natural whole number here. We just discussed natural number because that itself suffice, right, because it includes 0. Now
Yes, sir.
yeah, so natural number, then so integer is nothing but it's like whatever the extension of the natural number. Okay, so you are having from 0 to infinite, right? So let's, for example, if you are subtracting some bigger smaller number from a bigger number, or a bigger number from a smaller number, right? So you'll be having some negative values also. So integer is nothing but the expansion or the extension of the natural number itself. So you have something from minus infinite to infinite, all the integers value that you can get it. Okay, G, generally with the G, generally you represent an integer, and with N you generally represents the natural number. Okay, there are very basic stuffs like he has discussed about the multiplication, the exponential, and division and all. So multiplication is nothing, you're just adding the same number m number of times. Let's, for example, if you are adding, multiplying m times n, this is nothing, you are adding n m times or m n times. Okay, that is what you are doing here. uh, Sign and all, I hope you already know that. If somebody doesn't know, when you multiply two positive, you'll get a positive. If you are multiplying two negative, you'll get a positive. If one of the sign is the other sign, you'll be getting the negative as an answer. Okay, so those are very basic things. I'll just go a bit faster here. Okay, the only thing, maybe in the Python or maybe in the coding languages and all, you'll be learning, right? If you're writing a mod b, right, it will give you the remainder. Okay, so what does it means? Can somebody tell me what does a mod b means?
The
Is it like a
remainder.
dividing b or b dividing a?
B is
Divided
divided by A,
B is
then
dividing
remainder
A.
is 0.
Yeah, A is a
A
multiple of B or B is a
a
divisible
is
of A.
divided by b. Okay, and whatever remainder that you are getting, that will be answer. Okay.
Yes, sir.
What does this means? Okay, in
Yes.
Python and all, what does it return? Is it, does it return a boolean or what? Like a, what does it return?
It returns integer.
It will return true and false. Okay, what does this mean?
A divided B.
Bitwise
A
or
divides
Or
b.
operator.
A divides B,
A,
yeah.
correct. A divides b. Okay, so there should not be a confusion. If it is written a mod b, it's just that a is divided by b, and whatever remainder that you are getting, that will be your output. Okay,
Yeah, sir.
and if it is
Totally
written like
opposite, sir.
this, yeah, opposite, correct. If it is written in this way, that means a divides b, and then like it is whether it completely divides or not. So the output you'll be getting as a true and false. Okay, you'll be reading it continuously many times, then you'll remember it. As of now, it's fine.
Sorry to interrupt. There's
Yeah,
a above statement, the A mod B, where you are saying the A is divided by B.
b, and whatever reminder
Right.
that you are getting. Yeah,
Yeah. Now in the disability where you are saying that B mod A,
correct. B mod a should be
where
equals to 0 because a divides b completely. Okay, then only you'll be getting true and false as output, right? Okay, so if there is a confusion, what I was trying to say is, if you have been written a mod b, that gives you a remainder. Okay,
So it doesn't have any remainder, like it's
Okay,
divided
what will you
exactly.
get? 15 mod 4. What will you get as output?
Three.
3, sir.
3. 3 is the remainder, okay? And if I'll be writing here, uh, let's say example 5, 15. What will you get the output?
0, 0, sir.
Zero.
Correct. You'll be getting true because 15 is completely divided by 5. Okay. So this is how it works.
Yeah.
Nothing
Okay.
very difficult to understand. Okay. Okay. Now we'll learn about the
Yes.
factors. If you know, factors generally occurs in pair. Okay. So let's, for example, you have to write a factor of 24, right? Whether can be 124 or 212 or 3, 8 or 4, 6 or whatever the combination that you get, right? So factor generally occurs in a pair. That is what generally it is said. Not important, but yeah, you should be knowing those things. Okay. And if you have a perfect square, then the number of factor that you will be getting is odd a number. That I hope is simple to understand, because if you have a perfect square, let's for example 4, right? So normally you'll get what, 1 4 or 4 1, right? So we are getting even number as of now, but 2 2 you'll be getting, right? So that 2 2 you can't write it as 2 2 or 2 2, right? So you write first second, and this is second first. Okay, both are same, so that's why you'll be getting a odd number, because normally you'll get a even number for a number, but if you have a perfect square, you always be getting this combination of 2 2 3 3 if you are writing the factor of a 9 or any perfect square. So you'll be getting one number like this, that you can't have the opposite. Even though the order you will shift, the number will be same. So that's why for a perfect square, generally you get a odd number of factors. Okay, is this clear?
Yes, sir.
Yes, sir.
Yes, sir.
Yeah. Okay, and prime number,
Yes,
co-prime, all
sir.
this thing, composite number and all, I don't think so. That's like it's simple, like any number that just as a factor one and itself, those are prime number, and everything else is a composite number, right? Okay, mostly those are odd number. Only two is the exception, because two is even and then prime also. So that's the only thing. Other than that, divisibility, everything, okay, that's get repeated. So okay, it's fine. Now we'll talk about the rational number. We have talked about two numbers, right? We have talked about natural number, and then what we have talked about, integer, correct? So we talked about n, we talked about g. Now we'll talk about the rational number. This is also simple. Any number that can be written in the form of p by q, where q is not equals to 0 and p and q are the integers. So any number, 5 upon 6, 7 upon 8, any number where the denominator, so this is called as a numerator, this is called a denominator. Okay, and if the denominator is not 0, it's non-zero, and both like numerator and the denominator are some sort of an integer, right? Those are called as a rational number, except those, if you'll just remove the rational number from a real number, like, okay, I'll go to the real number, but yeah, rational number is clear. So any number in the form, generally we represent in the form of a q. In the exam, if it is written q, then you should be understanding that it's just talking about the rational number. So any number that is in the form of p by q, where p is numerator, q is denominator, and q should not be equals to 0, and p and q are the integers, then you call it as a rational number. Okay, you can see that all these numbers are rational number. 3 by 5, 30 by 50, all those numbers are rational number. Okay, so these are simple LCM and all. Okay, this is nothing but it's just talking about between any two rational number you'll be having, you can get an average of 2, and that will be less than the one, and the more than the other. Okay, so this is how it works. So if you have, let's say example, m by n and p by q, both are rational number. If you want to find one rational number that should lie in between, you can take the average, and that works for every number. It's not just about the rational number. It will work for any integer also. Even integer are also a rational number only. You'll see that when we'll talk about the sets and all. Okay, then we were talking, yeah, any doubt anybody has? Nothing, right?
Sir,
Yeah. Hmm. Infinity. Hmm. Hmm. I can't hear your voice. I guess there's some noise from, like, I can't hear you. Maybe you can write it in the chat box. Huh.
Sir, I have a question, sir. Sir,
Yeah.
what about say for repeated like a point form, like 0.333 something?
Those are also rational number, no? That's, for example, you are writing 0.33, right?
But so some number like 2.214, like
Those are not rational, no? Okay, I'll discuss that. Okay, so rational number we discussed. So real number is something like, see, you have something called rational number, right? We talked about something called number that can be in the form of p by q, where p, q are integer and q should not be equals to 0, right? So there's something called irrational also. Okay, so if you talk about a real number, if you'll just remove the rational number out of that real number, you'll be having a irrational number also. Okay, those can't be represented, right? In the, if it is in the form of p by q, pq are not integers. Okay, it can be in the form of, let's for example, root 2 or something called root 3 or something. Okay, some number. These are those number that doesn't follow whatever we were saying about the rational number. Okay, that can't be represented in the form of p by q, where somebody can say that root 2 by 1, right? But this numerator is not an integer. Okay, that is what I was talking about. So if something in the form of p by q, both pq should be some sort of an integer. Here root 2 is not an integer. Okay, that's why it's not a rational number, it's a irrational number. Okay, and if you'll talk about the somebody was talking about the repetition, right? The iteration in the decimal number. Okay, okay, sorry. Okay, there. Okay, so iteration somebody was talking about. So see, there are two types of decimal also. Decimal that terminates or repeats, right? Those are generally the rational number. Okay, if we'll talk about, let's for example, 1 by 3. Generally in the decimal you write it as 0.3333, that keeps on repeating. Okay, this decimal which repeats or terminates, okay, after some time. Okay, let's for example 0.265. Okay, that these numbers you can write it in the form of a p by q. Okay, p by q will be integer. Okay, this also you can write it as in the form of a p by q, right? 1 upon 3. Okay, keep on going, right? That's repeats. Okay, so the number is getting repeated. Okay, so decimal which repeats or terminates, those are generally the rational number. But for a irrational number, the decimal never terminates. It will keep on going. Let's for example, you're writing any number like root 2 itself, it will keep on going 1.414 something something keeps on going. Okay, or it will never repeat also. So the number will not get repeated every time. Are you getting me? Are you able to understand this? Let's for example,
Yes, sir.
Yes,
just
sir.
some
Yes,
famous
yes, sir.
number pi or some famous number e and all, right?
Mm.
There's
Yes,
something
sir.
3.14 something, it will keep on going. There won't be repetition or there won't be any termination of the number after decimal. It will keep on going. So I hope this clarifies the difference between the decimal that terminates and decimal that doesn't terminate. So two types of, right? There's a rational number, there's a irrational number. Decimal that terminates. Okay, terminate means 0.625, right? Or or repeats. Okay, it's like 0.3333 something. So those are rational number. So decimal that doesn't terminate or keeps on repeating. Okay, doesn't repeat, sorry. Let's for example root 2 or pi or e value, all those numbers are
Sir,
irrational. Yeah,
sir, pi is equal to 20 by 7, we can say.
no, that you can't say, no, those are not exact value, right?
Then
Generally
20,
for the calculation and all you write it as, but that doesn't comes like that. Yeah,
Sir, I
then
think
then
I
pi
can't
is
take a
irrational.
value of pi and exponential for.
what
I can't take a pi value or exponential for rational number.
you can't take, no, pi is the, what is the exact value of pi? So 3.14 some keeps on going.
As a fraction, 22 upon
No, as
7.
a fraction, but that is not same, right? Both are not same. Maybe for the
Okay.
calculation, for the mathematical calculation, you write it both as same, but those are not same. Okay.
That means 20 by 7 is a
Hello.
rational number.
Yeah, yeah.
Hello, am I audible?
Yeah, audible.
Sir, can you explain more than the
So what
rational
should I
and
explain it
irrational?
again?
Rational.
Pi. What is the
Yes.
exact value of pi? So compose some.
Hello.
See, but 22
Hello.
by 7 is exactly same as pi, not exactly. Okay. The approximate value of 22 by 7, you can say it as a pi. Okay. Is this clear now?
Yes, sir.
Yes, sir.
Okay.
Hello.
Both are not same. Those are like exact, not exactly same. So that's why you can't say. Yeah, yeah. Go ahead. Whoever was asking.
I wanted you to explain one more time that rational and irrational, like to understand the difference between both the character.
Okay, okay. I'll explain. See, rational number that I was talking about is nothing but any number that can be written in the form of p by q, and where q is not equals to 0 and p and q belongs to integer. Any number. Let's for example 2. Is 2 a rational number?
Okay.
Yeah,
Yes.
because you can write it in the
So
form
two
of
is the
p by q,
integer.
right?
So what if two is the integer? So what if 2.8, so that will not be considered as an integer.
Which number?
As a, if I write 2.1, 2.2, 2.21.
If you are writing root 2.
Yeah.
Okay, root 2 is not an integer, right? This is not an integer, right? Integer are all those
The
number 1
irrational
to.
number.
Yeah, so this becomes irrational number. Okay.
No, just now you have said that if I write 0.
No, first of all, your voice is not clear, so I can't understand. In between, it's coming and going. So, see, I'll just try to explain it from my side, and then if you are able to understand it, so I just wrote it
Sir
as a
is
any
asking that if we add any point between numbers, then what would be that number, like rational or integer? That's what
which
he's
number you're
asking.
talking about. Which number? Tell me the number.
Like numbers like 2.1, 0.3345, like that.
So I told you, na, decimal that terminates or repeats, those are rational number. So decimal that terminates, okay?
So what does terminates?
Terminates like 2.1. It got terminated, right? It got ended, right? After 0.1, right? If there was a number, something like 2.12567 and then 1, 2, something 3, 2. So this is not getting ended, right? Those are irrational number. See, this number you can write it like 21 upon 10, correct? And both are exactly same. So these are what?
Yes, sir.
This can be written in the form of p by q, where p and q both are integer and q is not equals to 0. So this is what? A
So it's
rational
a
number.
terminating number.
Yeah, if it is terminating, yeah, after decimal, it get ended, right? So you will be able to write it in the form of a decimal, or even it repeats. Whether let's for example 0.33, it's not ending, but the number is getting repeated, correct? So these both are also same, right? 1 upon 3. So this also you can write it as a say it as a rational number.
Sir,
Okay.
can we
Yes, sir.
write, sir, can we
Yeah.
write Q in decimal form?
Which q?
Q, P by Q, like rational number P by Q, 1 upon 2.5 something. Yes.
Yeah, you can write it 1 upon 2.5 also. That's fine. But if you
It's
like, let's
rational.
these are rational number only, right? 2 upon 5.
Okay.
See, is this clear now for everyone?
Yes, sir.
Yes, sir.
Yes, sir.
Yes.
Yes.
Yes, sir. Yes, sir.
Okay, if this is clear, then we'll move forward. So this is nothing. So at the end, I told you, right? The if you have a rational number and you have a irrational number, if you'll both get included, then you have a real number. So you have a real number real number can have this rational plus irrational. Okay, those are real number, right? But there are some other numbers also, right? Complex number. Those are generally the square root of the negative number. Okay, those are the complex. Okay, so there are something called complex number also that we don't have to read. Okay, we just have to read about the real number. The real number, okay, that includes rational and irrational both. Okay, then you have you were having a rational. Rational contains all the integer, right? And all the integer includes all the natural number. Clear? So if you have to go from starting to end, right? So let's say example, this is natural number. Okay, then you have this is what, integer. Then you will be having a rational number. Okay, this is rational number. Then you have a real number. Okay, and if you have to take the bigger one, this is a complex number. So everything comes under that. Clear? Yeah.
Yes, sir.
So in
If
the
you are not
lectures,
able to understand this complex, okay, leave this part. Okay, because you don't have to read again. Okay, till here you are able to understand. There's something called natural number, zero from infinite, zero to infinite. Then you have a integer, minus infinite to infinite. Then you have a rational number that can be 1, 2, 3 for anything, plus p upon q, any number. And then you have a, sorry, yeah, this is, and then real number that includes rational plus irrational, that whatever was left. Clear?
the
Yeah.
so in the lecture slide, there was a line, real number extend rational number. What it means?
Yeah, because you have some rational number, right? Okay. So let's, for example, any two number, right, between 1, 2, right? There will be a lot of rational number, but there are some irrational number also, like root 2. Correct? So you have
Yes, sir.
rational, and then you add all the irrational number, then you'll be having all the numbers, right? All the real number. Correct?
Yes, yes, sir.
Yeah, that is what I said, right? The extension of rational number. So you have rational number, you add some of the irrational number, and that will become all your number, real number. Correct?
Yes, sir.
That is what it said. Okay, so I hope this is done. Let's move to the sets and theory, right? So yeah, from now onwards, a bit of complex things will come. Those are also simple. Most of you would have already studied union, intersection, everything and all in your class 10th or 11th. But I'll just go through it, reiterate it again. Okay, so sets is nothing the collection of any object, okay, any element. You're just taking any random thing and then you're making a set. Those are all a set. Okay, let's say examples are days of a day or days of a week. So you have Sunday to till Saturday, right? Then you have a factor of 24, so you have all the values. So this can work as one of the set. Okay, and all the any set, let's say example, if you have to talk about the element, right? So what will be the number of element for the first set? If you are creating a set that contains day of a week, what will be the number of element? How many numbers the element can
Seven.
contain?
Seven.
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 Seven, right? Similarly, you have a factor of 24, right? You have some number here also, and then a prime number bit below 15. So you have this set that also will be having a cardinality. Cardinality is nothing but the number of element in a set. Okay, that you call it as a cardinality. Okay, in the exam it can ask, okay, given set, what's the number of element or what's the cardinality of this set? Okay, so that you have to think. And this I have already told you, this is a real number. Okay, so real number is a very big set. Then you have a rational number, smaller set, because real number has rational plus irrational, and then you have an integer, and then you have a natural number. So this, I hope you already know the hierarchy. Okay. One more thing. So order doesn't matter in a set. Okay. So this two important, very important thing. Let's, for example, I'm writing a set that has 1, 2, 3, or let's for example the first set itself, that was days of a week. Either I write it Sunday, Monday, and then Tuesday, Wednesday, Thursday, something like that, or I write it as Saturday, Friday, Thursday, Wednesday. So both are same set, right? So order doesn't matter in a set. Okay, so the number of element here also will be same, here also the number of element will be same. One more thing, even though you are repeating the number, let's for example you are writing Sunday 10 times, okay, and then Monday, Tuesdays, that doesn't change the elements of the sets. Okay, so if in the exam you have been given some sets and some numbers are getting repeated, and then you have been asked to calculate the cardinality or the element of the set, you just have to count the unique set. Okay, you don't have to count the repeated version. If it is written 1 2 2 3, then also the number of element, unique element, is how many? 3 only. Okay, and order and all doesn't matter in a set. We'll see in the relation the orders matter, the repetition also matters, but here nothing like repetition and order doesn't matter in a sets. I hope this is clear. So these two are very important properties of a set. Is this clear to everyone?
Yes, sir.
Yes, sir.
Which one is the prime number?
What?
Hello.
Yeah.
So I want to understand the how will I find the which one is a prime number, which one is factor. So is there any calculation is there to
No,
get to
prime number
understand
are
that
just those number who just doesn't have any other factor instead of one and the number itself. Okay, so you just have
one is number itself like
no. So any number, let's say example, you're taking 2, right? What are the factor of 2? Either 1 or 2, correct? There's no other factor. What about 5? You can't have any other factor instead of 1 and 5. So the 1 or 5, these two only can be the factor of that number. Those are called as prime number. Nobody is going to ask, but even though you should be knowing, okay, well, these are maybe you would have forgotten,
how
but
come
yeah.
like if how come 1 and 5 is a factor like so
Means,
either we are
sir,
calculating
that means
yeah
these numbers can't be divided by the other numbers, right?
See, a prime number are those numbers which doesn't have any factor
hmm,
instead of 1 or the number itself. Let's, for example,
hmm,
think of 4.
hmm.
What do
We
you
can
mean by
divide to
2 can divide 4, right? 4
yes
can
yes
divide 4, 1 can divide, right? So I
Yes.
just need those are the prime numbers which have just 1 or 4 as a factor. Okay, whatever number. But here 2 is also the factor of 4. So this 4 can't be a prime number. It's a composite number. Okay. So I hope this is
so
clear, right?
one cannot be like divide right
What one? One
if
can be
I
a
take
factor
the
of any
4
number, right?
huh one
So
can
that
be
is
factor
no. So see, prime number are those number for which only two values can be factor. Either one as a number, or the number itself.
hmm.
There can't be any third value that will be the factor of that number. Okay, you got it right. Okay, so can you tell me
That can
whether 15 is a prime number or not?
No, sir.
Not,
No.
it is not a prime number.
Not.
No, no, sir.
It's not.
No,
Not
it
a
is
Correct.
prime.
not.
It's not because you have 3, 5, so many other factors apart from 1 and 15.
15 and
So
1.
okay. I hope this
Sir,
clarify
if
your doubt.
sir,
Yeah.
if 50 is not a prime number, then what is this? It
It's a
is a
composite
composite one.
number.
So
Sir,
why it is
and
a
co-prime
composite
number?
number?
So, but I don't know why are you asking those things, these things.
Sir, what is the definition of composite number? Like if if do not have a two factor, after that it is a composite number
See, I don't know. See, prime number I told you, right? Only one or
itself.
the number itself.
Yeah.
Apart from this, all are composite number.
Okay. Thank you, sir.
Okay, if somebody wants to know co-prime is nothing but two numbers which has greatest common divisor, I call it as, right? GCD. As if those two number, the GCD are 1, then you call it as a co-prime number. That is what I feel the definition is for a co-prime number.
Uh, Sir,
Okay.
if you don't mind, what is two is composite number?
What is?
Two is prime number, sorry. Sir, two is prime number.
2 is a prime number, yeah.
No, two is PWIN.
TW?
IN, twins prime number.
Twins prime number. I don't remember. What is that? Maybe if some
Uh,
of you knows that, it's fine. I don't remember what is that.
Sir,
okay,
the
sir.
voice is a little bit low. Can you repeat which prime number?
Even he was talking. See, I talked about prime number. If you know, that is fine. Nobody is going to ask you that also. The remaining numbers which has factor apart from one and itself, those are composite number. Co-prime number, somebody asked. So two numbers, let's for example, those has the greatest common divisor as one only. Okay, so those number are co-prime number. I don't know about twins prime and all. There can be any different types of
I think
number.
co-prime and twin prime are same.
Oh, is
No,
it?
twin prime are
Sir,
one
on
prime number
Google it
plus
says
2. Like
here
5 and
says any
7,
number
11 and
with the
13,
difference
7
of
and
equal to.
like
Okay,
this.
that twins prime number are two prime number having a difference of two. I guess those are
Yeah, like 3
3,
and 5,
5,
5 and
5,
7,
7,
17 and 19.
11, 13. Yeah, but
Yeah,
those are not
47 and
important, but
50.
it's fine. If you know, is no. Otherwise, okay.
Okay, sir. Thank you, sir.
Okay,
Hi,
thanks.
what I'm saying, hello.
Yeah, yeah.
Like today I'm experiencing network issue. So later, can I watch your recording video?
Yeah,
Uh,
yeah, yeah. Yeah, yeah,
is
sure.
there
You can watch it now.
where I'll get it that
This is getting streamed on YouTube. Look, if you'll go to the IIT Madras online, like the
today
main
I'm
website.
facing a lot of network issue. Like multiple times I'm getting out from that.
Yeah,
So
yeah, you can
later,
watch it
if I want
later.
to
You can
watch the
watch it in the
recording
Google
video,
Sheet that has been shared by the
that
TA.
gonna be saved in the YouTube portal, yeah, somewhere else. It will
On the
going to
YouTube
be
portal
saved.
also, on the portal also, in your Maths One dashboard, the portal that you uses, there also the link will get updated. So there from there also you can watch the lecture later.
Okay, thank you.
Okay, thanks. Okay, so we'll move now to the next part. I hope till now everything is clear.
Sir,
Yeah.
sir, I have a question. Sir, can we write a set a collection of different well-defined items?
Collection of?
Collection of different well-defined items.
Yeah, yeah, you can write it. Anything and you can write it. You can write it one Dhoni 5. This is also one set. But that which set is that? Like, okay, that's fine. But you can have any different value. You just have defined. We are just defining a set, right? That's it. Any collection of a defined, well-defined item, right? Anything you can write. It's not compulsory, but there are some relevant sets. So these are some relevant sets. Days of, if you have to write it, the days of a week. Those are some relevant set. Okay. But you can write some irrelevant set also. That's not, yeah. Those
So
are
there's
also
a good
sets only.
example. So sorry, sir.
Yeah.
There's a good example of this the painting which the sir describes, where there are random objects which are placed in together, which have
Correct,
no
correct.
meaning together, but they are part of a painting.
Yeah, yeah, correct. These are some relevant sets. Days of, if you have to write it, the days. Okay, thanks, thanks for pointing it out. Okay, so we were discussing about the number of items, and we know that that those are the cardinality of any set. Order doesn't matter. Repetition, if it happens, you don't have to count it again. I hope can you please mute yourself? I guess this is repeating. Okay, thanks. Okay, so now membership and also there's some sign that you generally like that tells you x small x belongs to a capital X. If capital X is the set, then this is how you write if some elements, let's for example you have 1 2, right? Then you can write it as, if this is a set A, right? So you can write it as A1 belongs to capital A. Okay, this is a set and one is one of the element. Okay, so the small x belongs to capital X as element. So this is how generally you write it. Most of you know that, but okay. And this tells you that x small x doesn't belongs to. So this x is not the element of a capital X set. Okay. This is mathematical notation to tell you that x is a set, okay, and y is a different set. It tells you that x is a subset of y. That means what? Every element of x is in y.
So
Okay.
here X is a data type, right?
X is some set, okay, that has some elements. Okay.
Set is a
Let's
data type. One.
you can tell. Okay, let's for example
Set
here you are writing 1, 2, 3.
4.
Okay.
So it's a data
And
type. When
1, 2, 3, 4. Okay. Is X the subset of Y?
no.
Yes, sir.
Yes, sir.
Yes, sir.
So
What did I say? Every element
Yes,
of
sir.
X should be in Y. It's there, right? So X is a subset of Y. Okay.
Yes, sir.
Yes.
What about the proper subset? Anybody knows about the proper subset?
Yes, sir.
Which is
Yes,
not
sir.
X is a
where all the
subset of
elements are
Y,
null.
but
Yeah. The
Yes, sir.
equality should not
Okay.
hold.
Equal to Y.
Yes, sir.
Yeah. So the
Subset of
equality
Y
should
would
not
be equal
hold.
to.
Otherwise, that's fine. Everything is fine, right? If I have to write X for the same set, X belongs to Y. Does this hold? X is a proper subset of Y. Does that follow or not?
Yes, sir.
Yes,
Yes,
sir.
that
That
follows.
is also
Yes, sir.
correct.
Yes.
Yes, sir.
Yes, sir.
Yeah. The
Sir, yes.
equality should not hold. Okay. If the X,
If
let's for example, the set was something like this. Both X and Y are. Can we write it now?
No, sir,
no,
but
now it's not
still
a
No,
it
sir.
proper
is
No,
subset.
sir. It is
subset.
not
X
a
is
proper
not a
subset.
proper subset of Y. Okay.
No, sir.
Both are same,
No,
right?
sir.
Hmm.
So why this is so? Hello.
What? Yeah, go ahead.
Sir, my question is that why this is not actually proper subset?
Because for a proper subset, X should be included. Like X should be the all the elements of X should be in Y. Okay, but the equality should not hold because both
Okay.
are equal, right? X and Y both are equal.
So can you give another one example so that thing can be more cleared?
Any example, let's for example, you have X has an element, let's for example, 4, 16, 32, 64. Y has an element 32, 64, 4, 16. Okay. If somebody is asking, is X the proper subset of Y?
No.
no, sir.
No.
No.
No, it
No,
is
sir.
subset.
Yeah. It can be a subset, it's not a proper subset, okay? The equality
So,
doesn't hold.
So set is a data type. It will always start with the curly bracket.
Hello. Sir. Can you repeat again subset and sir, I'm a little bit confused between the difference between subset and proper subset. Can you repeat it again, sir?
so
If you don't
maybe
mind.
you could use real life examples like names or something, which could be easier for someone to comprehend.
See, the example, even though I use it name or 1, 2, 3, 4, I guess both are same only.
Yeah, I understand that. Uh,
Okay, I'll try to make understand it again. So I'll put it number
sir.
only. Let's for example, A is one set, maybe with X and Y or 1 and 2, right? And you have been given the another set 1, 2, 3. What did I say about the subset? What do you know about subset? Whoever has a doubt, can you just please let me know? What do you mean by a subset?
So subset is that
Subset
all the
every
element.
element of A. Sir, I have a doubt. Every element of A is also an element of.
Belongs to B. As I know, there's a subset or set is a data type. Always start with the like curly bracket, and it should be close with the curly bracket.
Okay, that is fine. Data types and all we are not discussing, but it's fine if you are knowing. But what I'm discussing is A and B have been given to you, right? A is a set that has 1 and 2 as an element, okay? And B is a set has an element 1, 2, 3.
Then how
Okay.
can it
A
will
is the subset of B.
Okay. So
Sir, all
now
the
if I'm asking, is A a subset of B or not?
Yes.
Yes,
Is a
What do
subset
you
of B,
mean by
sir.
a subset? Every element of A is in B.
In also B.
Is it there or not? One is the
Yes,
one
Yes,
yes,
element
sir.
that
sir.
is there. Two is
Yes,
the
sir.
one
Yes.
Yes, sir.
element is there, right? Okay. If let's for example I'm deleting this. Now A and B has a element 1, 2. B also has element 1, 2. Now I'm asking if does it follow or not? If now also A
Yes,
is a
sir.
subset of B or not?
Yes, so.
Yeah,
Yes,
yeah,
sir.
it is
Yes,
it
sir.
is a
Yes.
subset
Subset
of
means
A
what?
Subset
and
of
Every
B.
element of A should be in the element of B. Okay, if that is following, A is a subset of B. Now the second thing. Now we were discussing the second concept was the proper subset. Proper set. See, I'll just write a definition. Any set, a set A, is called as a proper. Is called as a proper subset of B if two conditions should hold. All element of A should be in B and A should not be equals to B. Okay, there must be one extra element in B. If there is no extra element in B apart from A, then you can't call it as a proper subset. Okay, so there should be one extra element. So now here A has 1 and 2 as an element, B has 1 and 2 as an element. Correct? Can you say that A is a proper subset of B?
No, sir.
no, sir.
You can't say, because
No,
what did
sir.
I say? There should be one extra element in B. You can say that A is a subset of B. That you can say. But if A is equals to B, that then you can't say that A is a proper. So there should be one extra element in B. Okay. Is this clear to you?
Yeah,
Yes,
sir,
yes.
sir, sir. What if in B 1 2 3 and in A 1 2, then B is the proper subset of A? Is it necessary?
No, then it no. Okay.
Sir,
What
can you
can
tell
you
the
just write
example?
it? B is what?
B is 1 2 3.
X equal to y, then after that what that symbol represent?
B
Which
is 1 2 3. In
X
B,
equal
which
to
elements
y after
are
that.
1 2 3, and A is equal to 1 and 2.
okay. Then what are you asking?
B is proper subset of A or not?
B is a proper. That is
No.
correct, right?
Correct.
B.
How it
Sir,
correct?
B.
No, that is not
B is
correct.
B
proper
is a
subset, I think.
That
So
is
it
not
is
correct. No,
not
the first
correct.
condition itself is not satisfying. No, the first condition itself is all the element of B in A.
No.
No, so the first condition is not satisfied, right?
Hmm.
Two conditions should be satisfied. First condition is whatever you're writing, right? If you're writing xy, right? A in B, right? A in B, right? You're writing. That means all element of x should be in y and y should have some extra element also. Then you call it as a proper subset. Okay. I hope this
Yes, sir.
clarifies.
Yeah, yeah. Thank
Sir,
you, sir. Thank you very much.
Sir,
Here I
may I
want to
speak, sir?
ask one question. What if
Hmm.
I remove the element of B, which is 3, and if I keep 1, 2, and A is a 1, 2, that is a proper subset.
What? Can you repeat it?
No, that is
No,
Please,
no.
guys, please wait a minute. If
One
I
extra
remove,
element.
yeah, if I remove
Second
the one
condition is
extra element
A does
from,
not equal to B.
I don't know what. Okay, this should not
uh,
be confusion, right?
no,
So
no.
let's say
I
example,
am.
you
Hello.
got it right.
Sir, give me a minute. Sir,
Hmm.
actually, what I think is the confusion, the thing where we are getting confused at, let's say for an example, we are having 1, 2 as a set A and element 1, 2, 3 in set B. Okay?
Okay.
So if 1, 2 is present in set A and it is proper and also present in B, right? So it is subset of A is subset of B. We are
Correct.
clear.
A is a subset of B. What's the confusion here? Yeah.
But while discussing proper subset, we are saying if elements are
A is a proper set of subset of B also in this condition. There is
Yes.
no confusion in
Yes.
that.
Correct.
What's the confusion?
There's
Let's
no
for example,
confusion.
set B contains all student of IIT Madras. Okay. And then set A is all student who is attending the live session now. Okay. Then you have been asked, okay, the attending student who were attending the class now is a proper subset of, like,
see,
let's
in
for
that
example,
case,
is
is
set
there
A a
a proper?
subset of B or not?
Yes.
Yes,
Yes,
right?
sir.
Yes, sir,
Yes,
it
sir.
is.
As a
Yes, sir.
proper subset also, right? Because A are a very
Yes.
small number of student, right? That will for sure come under B, and B has some extra element also. Correct? So that is a
So
proper
this is
subset
a
of.
so this is a
Yeah.
classic example of sample and population, I guess.
Correct. Yeah, that is an example of sampling Yeah, a population also. You can just
Whatever
consider this as a
condition that you have been
Is
wrote,
a
hello,
subset.
population, and this can work as a sample. Yeah.
whatever condition that you have been wrote, that set B equals to all student of IIT and second condition is that set A, like all students are attending that class. So is that
Today's
a proper set or normal set?
these are both, right? Both.
Yeah, both. But
Sir,
so
one
Proper
doubt.
here
subset.
the
See,
Proper
proper
subset
subset. You should not
can
begin.
be
Proper
subset.
subset is only one condition. Okay, there should be if we were talking about set A is a proper subset of B. There is only one condition that A for all student whoever attending our live session right now are the student of IIT Madras. And the second, the set B should be having some extra element apart from A, and that is also happening because this is a sample, is a population. Population will be having a very large number. Sample will be having a very small number, right?
And
And if
also
So,
sample
always
is equal to
sir,
population,
proper subset.
So this is sample, right?
small letters.
This is population. Okay.
but
Since
the
see in the
condition.
subset now equality can hold, this condition can hold. Okay, both, if both are merging, right, that can hold. Okay, set A I can write all student I in Madras, set B also student writing in term exam. Maybe let's for example everyone is writing in term
I'm just
exam.
I'm
Okay.
interrupting.
Yeah,
Just
yeah.
Sir,
sorry about that.
sir,
I
the
want to
second condition.
clear that second condition. I want to clear that second condition, which has A equals to 1 2 and B equals to 1 2 3, which has A is a subset of B, but A is not the proper subset of B. Right?
no, A is a proper subset of B. How is A not the proper subset of B?
It's,
A has 1 and 2, and B has 1, 2, 3. So it fulfills
See,
the
okay,
proper
to
subset
remove
function.
all your confusion, right? If whenever
I
two
said that
sets are
A is
same,
a
right?
subset of B.
But
No, no,
that's
A
not
is a
a
subset of B. A is a subset of B, but A is not a proper subset of B. Am I right?
No, it is a proper subset of B.
see.
It
Okay,
is
okay.
subset and proper subset
Proper
both.
subset can be subset, but subset cannot be proper set.
Correct. Yeah. See, I don't know. It's not like if
It's
it is
not.
subset, then it can't be proper subset, and if it's proper subset, it can't be subset. It's not like it doesn't work like that. I just told you one condition. Okay, there's one condition. Okay, if two sets has been given to you, two things can happen. Okay, and both can happen at the same time also. It's not like one is happening, the other will not happen. X is a subset of Y. Okay, it's this, you can see the sign, right? The equality hold here, right? Even though X and Y both are same, then also you can say that X is a subset of B. But if X is equals to Y, then you can't say that X is a proper subset of Y, because equality should not hold in a proper subset. If you're not okay, is it clear now or not?
Yes, sir.
So it is very
Crystal
clear.
Yes,
clear.
sir.
Yeah.
So
Okay. If it's
Clear,
clear,
we,
then
sir.
we can move ahead. I hope this is not that we should be giving this much of time. Okay. Okay. But if you have a doubt, you
Yes.
can
okay.
just
So
let me know.
so I have one doubt. So I have one
Yeah.
doubt from
Okay.
so the previous TA session, it was said that the real numbers are uh, they are like a proper subset of complex numbers,
That's correct.
right? But so the sir also said it's okay to use the equality sign as well,
Equality sign. How will you use equality sign here?
as in the subset sign, as in the subset sign. That's what the
So
TA said.
subset you can use the equality sign. Yeah. You can use it. Who is stopping
Okay,
you?
so that is not wrong, right? If it is written that way, that's not wrong.
No, if it is written in this way and you are saying that it's a subset, it's not wrong.
So yeah, okay. So real
Okay.
numbers, subset of complex numbers is fine with that sign
It's
that
a
you just
proper
pointed
subset
out.
also. That is also fine. Yeah. Yeah.
So
Okay,
can you
okay,
explain
okay,
one
got
more
it.
time, equal sign?
Janak, can you just post this in the comment section so we all can also once again go
Yeah,
through this?
yeah, I will,
We won't
I
take,
will, I will,
we
I will
won't
do
waste
that.
time. Thank you. Thank you.
Yes,
I'll
sir.
do
Hello.
that.
Can you sir explain it once more time for I do have confusion.
About what?
Proper subset and subset like this thing.
Okay. So I'll explain it again.
Sir, please explain by explaining all the four conditions. Then it will be good.
Like vowels are subset of all the alphabets.
Please don't interrupt in between. Otherwise, like people
भाई
speak
आगे
in
पढ़ लेने
between.
दो यार भाई.
Okay, okay. Do not.
Make it chaos.
Mm-hmm. I'll just try to make it simpler, but it is simple only. I don't know. I hope you are making it like if something. Okay, it's fine. Proper. So the way the symbol is pretty simple. Okay. Here you just write it as B. Yeah. Here it is written that all elements of A are in B. Okay. Here also all elements of A are in B and A should not be equals to B. That's the only extra condition. That's it. So the equality is allowed here, but here it's not allowed. Okay. So the size of A and B here it can be maybe equal. The size of A and B or the number of elements in A and B here it can be equal. It will always be smaller. A will always be smaller than B. Okay. You need some extra element in B firstly.
So that is exactly my doubt about the real numbers because real numbers are never equal to complex numbers.
That will always be smaller, right? So real number is a smaller subset of complex number. What's the
So
doubt?
so can you just so we sir mentioned that you can use both the symbols. It does not matter, but when the real numbers are never equal to the complex numbers, how can we use the one with the equal sign? Is my question.
Okay. Okay, it's just a
Okay.
way of representing. It's okay. See, let's for example, you have A equals to 1, 2, B equals to 1, 2, 3, C equals to 1, 2 again. Okay. If I'm writing A, is it right or wrong?
It's
It's
right.
Yes, sir.
true.
It's
Right,
right.
right, right.
It's right. Even though
Yeah,
I
yeah.
can use the equality sign here, it just says that A is a subset of B. It doesn't mean that A and B are equal. Okay, so in the same way, you can write it as real number is a subset of complex number. Doesn't mean that real number and complex number both are same. It's just a way of representing. Okay, you can write it. You can write this also. Is this correct?
Maybe.
Yes,
No.
sir.
Yes.
Maybe,
Yes.
sir.
This is also correct because A is a
Right.
proper subset of B and B has some extra element apart from A. A and B are not same, so you can write it this way. Okay, now the third thing. Can you write it this?
Yes, sir.
Yes.
Yes, sir.
This is also
So
correct. C is a subset of A. Totally correct.
Sir,
Because
what is the
C,
representation of proper subset?
this is how you
Oh,
represent
oh,
proper.
sir, I think it's getting too stretched out. You can ask the ones who still have a doubt to maybe look at some other references which you can find online because this will just consume a lot of time if you keep looping over the
सर
same.
इनको छोड़ो सर, इनको आने वाला नहीं
Okay,
है सर,
hey,
आगे
hey,
पढ़ाओ सर.
please, please keep. I'll go. I'll go. Okay, but it's fine. If you are understood,
आधे
it's
घंटे से सर
totally
हम वेट कर रहे हैं कि अब इनको समझ
okay.
में आएगा, आ ही नहीं रहा है.
Okay,
Okay,
relax,
okay, it's
relax.
fine. Relax. Okay, many a
But
times.
class are equal now, like you catching
Okay, okay.
everything. You have lots of IQ, but everyone
Okay, okay.
IQ
Yeah,
No,
have
no,
yeah.
don't take it personally. It's
Yeah,
just
yeah.
I
It's
think we
fine.
need
It's
to,
fine.
yeah.
Even I was the one I was not able to understand, so I
Like
tried making you think
got
it's
So we
fine.
could also
like
say ki, the means of transport is the population, and then just like
Correct, correct. It's
scooters
just
and two-wheelers are like a subset of
Mhm.
vehicles. Yeah.
Correct, correct. See, okay, so we'll move to the next topic, but you can just take a reference. If you somebody, I will just write it on the discourse also. If you want to go and refer that also, that's totally fine. I'll try to elaborate on the discourse. Maybe why students are getting confused because you're thinking that if you can write it as A is a subset of B, you can't write A is a proper subset of B. That doesn't work like that. Okay, so okay, leave it. We'll move to the next portion. The next portion that we'll be discussing about is the Venn diagram. The subset we have discussed. Okay, so cardinality we have discussed. Cardinality is nothing the number of elements that is there in any set X. Okay, a set X has been given to you, so the number of elements, the number of items, both are same, and both, if you have been asked regarding the cardinality, all three are same. There's something called infinite set, something called finite set. Finite has some finite number, infinite has, like, let's for example a set of natural number that will start from 0 to infinite, so you can't count the number. So those are the hierarchy we have already discussed. Okay, you can see that. Okay, somebody is asking, right? So you can see that, right? Q is a proper subset of R, and then G is a proper subset of Q, and N is a proper subset of Z. Okay, you can write it in this way. Now we'll talk about the power set. This is also pretty simple. Power set is nothing but set of all the subset of any sets. Okay, so let's for example you have A and B. These are not important. I don't think so. This is discussed also. If it is discussed also, just know that how can you calculate if you have been asked to calculate the cardinality of a power set of any set. Okay, then what can be the number of that number of elements that will be there in a power set. Okay, so if you have been given something like AB, okay, so this 4 phi or A B or AB, all four can be the set, can be the element of a power set of a set. Okay, so it works like in the lectures it was defined, or even though you can just think of as AB was the element, right? So let's for example you have there is some formula also. Yeah, the formula has been written here. The number of all the element of a uh, all the element of the power set, all the element that can have that is there in the power set of a set. Okay, so those are 2 to the power n, because you just think in that way. You think it's like let's for example 4 number was there, so you just think in, or 2 number was there, you just think it whether it can come or it can't come. So in that way it will be 2 to the power n. Okay, so this is how generally maybe the formula was this, like.
Sir,
Yeah, yeah.
power sets are also known as the supersets. Huh?
Power set are also known as superset of what?
Superset of, I mean, superset and subsets. Power set is also known as supersets in many textbooks. So that's why I'm asking.
I'm not aware of that.
Actually, the
Somebody is aware,
definition
you
is
can
too
just
much
let.
similar.
What?
Definition is too much similar because the power set have all the elements of the subset, and here also, sorry, superset have all the elements of subsets. Here also, power set has all the elements of subsets. That's why.
Okay, I'm not aware about the superset. What do you mean
Okay,
by
okay.
super?
Super is
Sir,
also
like
power. Superpower, same actually.
sir,
Like my
like A is a
textbook
You are
subset of
contains
talking
B,
about
super
but
set.
B is
universal
a power
set.
set of A.
Universal set.
No,
Okay.
it's fine
No,
actually.
universal
I
set
got it.
is something totally different from a superset.
Yeah,
What
yeah.
I mean, yeah.
We don't have anything called superset in our syllabus,
Yeah,
right?
and superset is quite different from power set. I just read, so it's not the same.
Yeah,
We
yeah.
don't have that in our syllabus, right?
Yeah, it is
No,
not in
no,
the
no,
So
no.
syllabus
let's
as well.
we don't have to confuse. Thank you.
Okay.
We can carry on, sir.
Okay. Okay, so the number I told you about the inclusion and from exclusion, you can calculate the cardinality of a number of element in a power set. That will be 2 to the power n, and that's pretty simple. Okay, so this all things will move to the most important portion. So this comprehension, I'll come to this portion again, but I want to discuss the most important part that we should not be leaving, the relation. Okay, so set we have discussed, a brief about the set we have already discussed. Now we'll learn about the most important portion, and most of your questions will be from this relation portion itself. Okay, because the function will be discussed again in week 5, 6 and all after quiz 1. So that's why generally we don't ask anything about functions. Maybe you can be asked whether this given mapping is a function or not. That's it. You'll not be asked regarding whether it's an injective function, surjective and all, onto, into and all, because everything you'll be learning in week 5 from after quizzes and all. Every questions, most of the questions that you'll be getting in the quiz paper, like for a quiz paper that has already gone, every week you'll be having some 3 4 questions will be asked. And I can tell you from this week first itself, whatever you have learned, right, natural number and all, those are totally fine, because those are just work as a base to solve the questions. But the questions that you'll be getting mostly from the relation itself, function will be asked later. But yeah, All the questions, maybe 3 4 out of 4 questions, 3 questions will be just from the relation. One question you can get it on Venn diagram or maybe a set theory, cardinality, all those things. But yeah, so this relation portion is important. And if you'll just go through the previous term paper also, you'll just get an idea that every question was from relation, whether this relation is a transitive, symmetric, like reflexive or not. So every time they'll be asking the same questions, keep on asking the same from the same person. So that's why I just want to put a lot of effort here. So if we'll discuss about the relation, relation is nothing. If you have to talk about like any two sets you have been given, right? Any
Even
mapping that
also
you create,
final
okay?
exam hall, we will be getting the same exam, same question,
Same question as
like whatever we are doing, like whatever question will come in quiz, that the same kind of question we are expecting in final exam altogether, right?
I will discuss those type of questions that can be asked in the next
Yeah,
session.
yeah. I'm sorry.
Huh,
He is
those.
trying to build the concept. You just
Huh.
focus on the concept.
Okay, next session we'll be discussing some 20 questions that will be on the similar pace of that will be asked in your quizzes. Okay. So let's for example you have been defined relation. Okay, so any set has been given to you, set A and set B. So any type of mapping are called it as a relation. Okay, any two set you take and any type of mapping. Okay, so let's for example set A was having one element 1 2 3 and here it was A B C. Any mapping was done, right? You can write it as some element from, so here let's for example A and B. So if you have to just create a relation, right? A relation B, right? This is how generally you write a relation. Any mapping, okay, can we call it as a relation, okay, from A to B set. Now I'll talk about something called Cartesian product also. So Cartesian product is nothing but, let's for example you have been given two empties, two non-empty set. So if you have been given two non-empty set, let's for example x and y, okay, that has some element, this also has some element, okay. So if you want to write an ordered pair, any ordered pair you want to write it, one element from x and one element from y, okay. So let's for example you want to write it xy such that x coming from capital X and y coming from capital Y, okay. Any ordered pair that you want to write it, okay, for this x and y, bigger set x and y, whatever the ordered pair that you will be getting, that can work as a some sort of a Cartesian product, okay. So that you define it as, write it as x cross y, okay. Everything is getting same, so I'll just write it as A as a bigger set and B as a bigger set, okay. A has some element, B has some element, you want to write it as a odd in the form of a ordered pair, one element from one set, other element from a other set, okay. So we are writing something like yeah, from here you are writing x small x and from here you are taking y. A has some element, B has element, and you wrote it down a different sort of a ordered pair. Those can work. Generally, you call it as a cross B. So A cross B is nothing but you're just taking one element from one set and the other element from other set. Maybe with the example, it will be more clear. Okay, so here it has been given. So if you have to define it x cross y, so what you are doing, you're just taking x y, x from one element from x and the other element from b. So you have element A, B, and 1, 2, 3. So here it is A, B, and here it is 1, 2, 3. What you want to write it as? All the ordered pair that you can get it from these two. Okay, so all the ordered pair will be what? A can be ordered with 1, A can be ordered with 2 also. So you write it as A1, A2. Okay, B can be ordered with 1, B can be ordered with 2, and B can be ordered with 3. So this is the whole Cartesian product if you have been given two sets A and B. Any relation R, let's for example from A to B, will be a subset of this whole A cross B itself, right? Because let's for example I want to get a relation such that A must be related to 1 in some way, any relation, and B is just related to 2. So what will be that relation? That relation is A comma 1 and B comma 2, okay. And you already know that this for sure is a subset of the whole ordered pair that we were having, okay. So whenever you have been given two sets, A, B, any sets has been given, and then you have a ordered the Cartesian product of those two sets. Okay, so and you have to get some relation. So whatever relation that you are having from A to B, for sure that will be a subset of the bigger Cartesian product A cross B. Okay, so in short, relation is nothing but a some sort of a ordering or some sort of a mapping that you have from one set to another set. That can be that there is nothing fixed. Okay, that relation is something that you have fixed. You can have any sort of a relation from one set to another set. Okay, is this clear about the Cartesian product only?
Yeah.
Yes, sir.
Yes,
Okay.
sir.
Yes, sir.
Yes, sir.
Okay, now so you were having two sets A and B, so you got it A cross B, and you can have n number of different types of relation in from A to B. One relation can be A1. This is the only relation R1. Okay, R2 can be A comma 1, A comma 2. Okay, this is one type of a relation. All this relation that you are making from A to B, for sure that will be a subset of your Cartesian product A cross B. Okay, so this was all about the relation, and now we'll discuss about how many different types of relation can happen, or different types of relation that generally we read in our courses. Okay, see, so A cross B that we got, this was what the Cartesian product of two non-empty set. Okay, any relation, let's for example you made R1 as a relation. Okay, that can work that generally you call it as a binary relation. Okay, so some relation A to R. So some sort of a relation this is between A to B. Okay, but our Cartesian product was a very big set, right? Out of that big set there is one relation R. Okay, there can be something A R1 B also. That R1 can be anything A comma 2 B comma 2. Okay.
May I interrupt?
Yeah, sure.
In the previous example, you mentioned like A is related to 1 and A is related to 2. So, won't that violate the like one single output can't give
No, that
two?
happens in a function.
Okay.
So function is one of the type of a relation where you have one input and then exactly one output. Okay, that is what is function is. But in a relation, it can happen anything. A can be related to 1 also, A can be related to 2 also.
Fair enough.
Yeah,
Okay.
can we? I have one doubt that can we like compare it with a like cross join in like SQL? Like, is it the exact same thing?
Cross join. Yeah, correct.
Yeah, fine.
So there won't be any empty set in Cartesian product, right?
There won't be any empty set. Then there is no relation, right? That is also can be like many of the. See, let's for example, empty set you're talking about. That's not a relation, right? There must be some relation from if you are mapping something, right? 1, 2, 3, 4, right?
Wow.
A, C, D. There should be some mapping. Let's for example, 1A itself. That itself is one relation, 1A. Okay, but if you're not having a 5 means there is no relation, right?
Yeah, I understood.
You got it, right? Yeah. Okay. So this was a relation, but there can be different types of a relation, right? You already know that, right? If you have two sets, right? Set A and set B, and set A has n elements, set B has n elements, right? So you can have different types of relation, right? From where, and out of those relation, there are some relation which are a bit peculiar, and those relation that you call it as a function, where there's the mapping happens in such a way that the mapping from A to B is a bit unique, right? You can't have from, let's for example, one input, you can't have two outputs. Okay, you just have one input and one output. One output means like you can directly map it to only one element. You can't map A to C also. Okay, so those type of relations which have just exactly one input and one output, okay, those you call it as a function. Okay, so function is also a type of a relation in which every element in set A is mapped with exactly one element in set B. Okay, is this clear? So if you know about the function, function is also one type of a mapping. So you write it function in such a way. This way you write, right? This is how you write a function. You write in such a way that if you'll put the value of x here, you should get some output. Correct? That means if you are putting some input, you should get some output. Okay. Now let's, for example, there is a mapping A and from B in such a way that the mapping was such that A, B, C, D, and A was mapped to 1 also, and A was mapped to 2. Okay, this can be one relation, but is this relation a function? No, because whenever you were defining a function, f of something should get an output, right? Now, if I'll put f of a, what will be the output? I don't know. Whether I'll get 1 or I'll get 2, that I don't know. So that's why this is not a function. This can be a relation, but this is not a function for sure. Is this clear to everyone? Which type of relations are function?
Yes, sir.
Yes, sir.
Yes,
Yes.
sir. Yes, sir.
Yes, sir.
Yes,
Okay.
sir.
Okay, so
Yes.
that's why whenever you were checking about a function, right, there is something called horizontal line test. Okay, so let's, for example, you have been given a graph or a mapping. Okay, let's, for example, this is a mapping. Now, for one fixed input, you are getting two outputs, right? So this is also not a function. This graph or a mapping that has been given to you, it's not a function. Is this clear? Because at one x
Yes, sir.
you are
Can
getting
you
two
repeat
output,
this?
Yes,
right?
sir.
This is
Can you
y1,
repeat
this
this?
is
Yes,
y2.
sir. Yes,
Y2.
sir.
Okay,
Yeah.
so whenever you have to check whether the given mapping is a function or not, what you can do is whatever graph has been given, you just drop a horizontal line, and if that horizontal line is somehow like cutting the
Sir, it's a
graph at
vertical
2 point,
line.
okay,
It is vertical line.
sorry, vertical line, yeah, it's not horizontal, is for the injective and all. Okay, so vertical line, if you'll just drop a vertical line, right, if it is cutting at 2 or more than 2 point, okay, so it should maximum it should cut at 1 point. Okay, if it's cutting more than one, then you can directly say that at one input you are getting some two outputs. That is not possible for a function, because in a function you just can put only one value. You can't, you can put one value and the output should also be one, otherwise it is not a function. So I hope this is clear. The basic idea about the relation and function is clear. Now,
Yes, sir.
how
I
many
have
different
got
types
one.
of a relation can exist? Yeah, yeah.
Suppose, sir, in the set, like you can see that if you go slightly up
Hmm.
in the slide, yeah. So the sets are represented like the all the relationship are written as one comma a comma two, something like that. Okay. Suppose in the set all the element are same. Suppose set A has a and set B has triple one. Okay. In that case, the relationship would be like one. All the relationship would
No, see the
same.
mapping. So here the mapping
Hmm.
was from set A to set B, correct?
Yeah.
So this is set A, this is set B, this is set A, this is set B, A, B, 1, 2, 3. So the mapping can't be AA because
No, no,
uh,
I'm not saying that. I'm saying suppose set A has only A dot 2A, and set B has 3, 1.
okay, so you're saying that set A just has A and set
Hmm.
B has.
Suppose 2A, not only one, a
We
single A.
already learned that the order doesn't matter in a set.
It's not.
But in relation, order
Repetition
mattered.
doesn't matter.
No,
But
Repetition.
2A,
in
suppose
relation,
Yeah.
2A is
it
there, not
will
single
matter.
A.
In a
Element.
set, A is a set, and
Cartesian
A has
doesn't matter.
Yeah, whatever she is
No,
saying is correct. Because in
yeah.
a set, the order doesn't matter, and the repetition, if you're repeating, that doesn't mean. So in the set, the repetition should not happen. Okay, if it is happening, also that's not a like. If you're writing A, that doesn't mean you have two A. It's just that you just have a one A. If you're in a
Yes.
yes, sir.
function, you're putting one, right? One can be even you're
Yeah.
writing one n number of times. That doesn't mean one will be different, right? One is same, right? Are you
Yes, sir.
getting? Yeah. So if you're
So,
putting some
yes.
input, right? You can't have this one is different, the other one is different, right? If you have a function x square, one if you'll put, you'll get the same output, right? So,
Yeah, I have to take the unique values. Okay.
it should be okay. So,
Sir, A cross B is equal to B cross A. Is it
no,
No.
those are
possible?
not. Those order in a relation matters a lot. Okay. You can't write it
Uh,
1 comma 2 is not same as
s-
1
uh,
comma a. Okay.
so the simplest example is a father to a child or a mother to a child.
Correct, correct. Yeah. That can be a one relation. So that doesn't occur, right? If I'm So somebody's child, right? Opposite can't happen, right? Is this clear?
Yes,
Yeah,
sir.
yeah, yes, sir.
In friendship and all, it can
Yeah.
happen, but it's not. Yeah. Okay.
Yes.
So now discuss the properties of relation. Okay. I have some. Yeah. So I have written it here. There are some relations. So this Cartesian binary we have discussed. Now let's discuss about the reflexive relation. Okay, so there are some properties of relation. I told you, right? Some relations can be function also, but there are some properties of a relation also. Those are very important. Okay, so these three you should be knowing. Apart from these three, there can be different types of. Those are like you can learn it, but those will not be asked in the paper. That I can assure you. So three types of relation mostly will be asked: reflexive, symmetric, and transitive. Or maximum it can be asked if all three occurs, then equivalence relation. It follows equivalence relation or not. The first one is the reflexive. It's pretty simple. It just says that let R be a binary relation on a set S. Okay, there is something called set S. Okay, so there is something called set S. So this is set S, and this is also set S. Okay, on S you have to make a relation. So S cross S you have some Cartesian product. Okay, now it has been said that R is a set. R is a relation on R is a relation. So there's something called S R S. Okay, so there is something called R is a relation on S. Okay, and it has been said that whether you have to check whether it's a reflexive or not. So the very simple definition, if you have to check whether R is a reflexive relation on S or not, you just have to see that it can only this R can only be reflexive if and only if all the element whatever for all the element that is present in S. Okay, in this element S, XX should be present. So let's for example here 1 2 3 4 is given. 1 2 3 4 is given. This any relation on S can be reflexive only if it contains 1 1 2 2 3 3 4 4. Apart from this, you can have anything, but this 4 must be there. Okay, then only you can say that this is a reflexive relation on S. Is this clear? So any relation R, any binary relation R is a like binary relation R on set S is called to be a reflexive if and only if all the element those are present in S, it should be in the form of XX or whatever number AA should be there in that relation R. Otherwise, it will not be a reflexive. Apart from this, if you have, let's for example, 4 element, apart from this 4, you can have anything else 3 4 2 3 1 2, anything else can happen, and that will be a reflexive relation. But these 4 for sure should be there. Is this clear to everyone?
Yes, sir.
Yeah.
It means
If
it
it's
is
just tell me
identity.
out of this R1, R2, R3, which all are a reflexive relation?
Sir, what is identity relation?
Okay, I'll
No,
go through that. Just
R1.
let me.
R1 is
R2,
R1, sir.
R2
Sir,
is
Sir,
not
sir,
R1
just
R1
write the
R3.
example.
R1 R3.
Only R3.
Sir,
R1 and R3
sir,
both.
what?
R1 is
Sir, sir,
identity.
Sir, only
R1
R1 is the reflexive
R1 is
Or
identity,
identity.
relation.
which is
No, no,
subset of
R3 also.
which like
No, R1 and R3.
okay.
all are
Uh,
reflexive.
sir,
no, no,
R1
only
is
R3.
identity and
Okay,
reflexive,
okay, okay.
but
I
R1
got
and
it. I
R3
got it.
are
I got it. I got
reflexive.
it. So whoever said R1 and R3 are the reflexive, you are totally correct. I feel like somebody who is just saying that all three, you have done, maybe you would not have seen it correctly. 3 3 I guess is not there. Okay. So, and I guess, yeah, 3 3 is not there. What I said, to become a reflexive relation, okay, all the element, so here you can, if and only if all the element, all X that belongs to S, XX should be there. So if 1 is there in S, 1 1 should be there. If 2 is there in S, 2 2 should be there. 3 is there, 3 3 should be there. 4 is there, 4 4 should be there. If it was 5 also, then 5 5 must be there in that relation R. Okay, any of this 5 or 4 are missing, that will not be a reflexive relation. In R1, for all 4 are there. This is identity relation also. Identity is nothing but if you have 1 1 2 2, only those things. Apart from this 4, if there is anything else, then that will not be identity relation. But this is R1 is identity plus reflexive. So all identity relation are reflexive. So this is identity plus reflexive also. Identity is not important. You don't have to read, but okay, if somebody asks, that's fine. Yeah, this is a reflexive relation. The second one is not
Sir,
reflexive because 3 3 is not there. So it's just that 3 3 is not there. That's why it's not reflexive. Okay, it's not identity also because yeah, the R3 you 1 1 2 2 3 3 4 4 all four are there. This is not identity, but this is a reflexive because I told you this four must be there. Apart from that, anything else can happen. Anything else can come, but this four must be there for to become a reflexive relation. Yeah, doubt if you have, just let me know.
Sir, can you share this slide, sir?
Can you?
Sir, upper.
Can you share this slide, sir?
Yeah, I'll upload each and every slide that I'm using. Yeah.
Sir, I have one doubt. Sir,
Yeah.
you mentioned one thing
Sir,
like
when will
S
this be
and S,
uploaded?
S and
In
S,
week one?
1, 2.
Where will these be uploaded, sir? In week 1?
Yeah, in week one supplementary content, we'll make a folder, something like class notes or class slides. There you can find it on the dashboard. Or for the first week, I'll make sure that it'll go. I'll mail also. Okay, to everyone.
Thank you. Thank you.
Huh.
Sir, my doubt is, sir, you mentioned like two sets, sir, S and S, sir. So, sir, just confirm it. It could be same. What if 1, 2, 3 is S side and another S side is 1, 2, 3, 4?
See,
Hello.
okay, I got your point. What you are trying to say. See, whenever you have been asked, right, any set on S. Okay, if it is written something like that, right, and only S has been given to you. Okay, so you're just talking about S cross S.
Mm-hmm.
Okay,
Yes,
so
sir.
if it is, yeah, if it is written like you have R be a so binary relation on S. Okay, that means you just have to check for S cross S, nothing else.
Okay, so sir, single set, how can we make S cross S, sir, in a single
S,
set?
you have 1 2 3 4, right? You have to make it cross, right? S cross S will be all the contents. You have 4 element here, 4 element, the same 4 element will be in the other S also, right?
Okay, sir, got it, sir, got it.
Okay.
So,
So what if sir, if we have two sets, sir, okay, S is equal to 1 2 3 4 and another set is 6 7 8 9. So if we cross both of them and we make it reflexive, is it possible?
No,
Sir,
then
draw it. Sir, draw two charts, sir. Draw two box, yes, sir. And one box you write you will write, sir, 1 2 3 4, and then another box you write, sir, 5 6 7 8, and cross all of them, sir. Like 1 to 4, 1 to 5 and 2 to 6 and 3 to 7, as like that way.
there
But
would not be any reflexive.
sir, sir has told that reflexive is defined only on one relation, only on one set. Sorry,
see
why you are taking
reflexive.
two?
Okay.
Yeah, it
Okay.
makes
Again, I told you about
sense.
this point, right? On set S. Okay. If it is, see, reflexive relation makes sense only when you are talking about some relation that is a subset of S cross S. Okay. You can't make it S1 cross S2. Okay. Then the reflexive relation doesn't make any sense. I hope this is clear. Okay.
So,
Yeah, sir.
Yeah.
Clear, sir. Thank you, sir.
So, but if the S1 have 1 2 3 4 and S2 have 1 2 3 only, then there would be combinations of 1 1 1 2 and then 2 1
Then
2
if
2.
both are S1 and S2 both are same, that makes
They're the
sense.
same.
One,
They're the same
If
set.
both,
just
yeah.
yeah, but it's like a S1 is a subset of S2 now, because S2 has just one more element and S1 has all the elements of
Okay, I'll
S2.
just write on.
Just think about it as like the Indian cricket team. So if you have the replica, it is still the same team.
Okay, but at that time when S1 and S2 are different set, even though they have same elements and just one extra element in other set, then
No, then
the
no. Okay, so
Then
see,
they are different sets, and you cannot do that.
a relation between
Yeah, but I'm just
different
saying
set
that
is just a
if
relation. Different sets is simply a relation. Okay, you can just note I'm just trying to tell you that a relation between two different set is just a relation. Okay, but if you have to get reflexive, symmetric, transitive, these are all defined on a sim set. Okay, so it's like a binary relation on this.
So all these three types are defined only on itself. That's what you're saying.
Correct, yeah.
Okay, got it. Thank you so much.
Yeah.
Sir, in reflexive,
Just a small doubt.
Yeah.
Just a
Sir,
small
can you
doubt. Like
explain?
every inequality relation is not a function.
Every inequality.
Yeah.
If you can give me.
For example, x is greater than y. In the relation, there is a equation like that. So it is not a function, like we can say, because for example, it is taking for every for every x there are multiple, sorry, for every y there is multiple x, you can say, like in inverse, vice versa.
I don't think so. All an inequality relation is a function. See, if let's for example, just think any. So you're talking about any relation. Let's for example a relation such that xy such that y greater than x.
Yeah.
Yes.
Correct. So
Yeah.
here, but this will not be right. Here it can be
It'll
one
never
in.
be a function. It'll never
It
be a
can be a
function.
function, right? One input. Let's for example x equals to 2. Y can be 3, 4, 5, 6, everything, right? One input, multiple output. That can't happen, right? For a function, it
Yes.
should be one input and you should be getting one output, right? If you are putting in a
Yes.
function something, right, in box, some output should be there. Here, if you are putting 2, it is coming out to be 3, 4, 5, 6, anything can come, right? So this is not a function.
so
Yeah,
so
that's
in the
completely my
fu-
doubt.
Yeah.
so in the future, when we are away from the functions, for the normal relations, there would be reflexive relations for S1 and S2, if I say.
Yeah, can you reiterate? I didn't. Can I
I
go
mean,
through that symmetric and transitive and then
yes, yes, yes.
can you
Okay.
come to the doubt? Yeah.
Yes,
We'll
yes.
Yes.
discuss your doubt. Yeah. So first reflexive
Sir,
is done. I mean, anybody has any doubt in reflexive relation?
sir, in reflexive, can you explain that
No,
part,
sir.
sir? S
No, sir.
XX is a element of R, sir.
Axis is element of, okay, this one, huh? Okay. What?
Yeah, in definition, sir, XX is element of R, sir. That part, sir.
Okay. What I was saying is, let's for example, this X is just let's for example, S has element A, B, C. Okay. So this X means it's like a iteration that you run, right? In a loop that you run in a Python or any code, right? This is X1. Let's for example, X1 is A, X2 is B, X3 is C. Okay, it's just saying that for all X means X1, X2, X3. Okay, for all X, if A is there in S, so AA should be there in that relation R. Okay. Similarly, X2, it will go again, and X2 is B, right? So BB should be there in that relation. CC should be there in the relation. Okay. And if you have this type of a relation, then it's a reflexive relation. This is what it's saying. Did you
Okay.
understood or not?
Okay, got
Yeah,
it, sir.
you got it. Okay.
Yes, sir.
Okay. Let's move to the next part now. Symmetric relation now. So symmetric is nothing. This is also very simple. So any relation R is said to be a symmetric if and only for every xy. So you just you just see it very carefully here. For every xy that belongs to R. Okay, it's nothing related to S here. It's related, like all the elements that are there should be from S only. But the most important part is xy. If xy is there in R, yx should be there. Okay, let's for example, there is one R. So S is here 1, 2, 3, 4. I have one relation R that is something like 1, 2. Okay, is this a symmetric relation?
No, sir.
No.
This is not a symmetric
No, sir.
relation. Why?
Because 2, 1 is not present.
Because
Correct. This is 2, 1 is not there. So I don't have to
not there.
worry about each and every element of 1, 2, 3, 4 because I don't want all the combinations. 1, 2, 2, 3, 3, 4, all those combinations I don't want. I just want if xy is there in R, yx should also be there in R, should be there in R. If it is there, then it's a symmetric relation. Okay, so now tell me, out of R1, R2, R3, which all are symmetric?
No, sir.
R1 and
R1 and R2.
R1 and R2 are the symmetric one.
Okay,
R1
why
and
R3
R3
is
are
not there?
symmetry.
Why R3 is not
Because 4,
symmetric?
3 is not
Because
4, 3 is not there.
1, comma 2 or 1. Yeah, sir.
Yes,
Yeah,
sir.
sir.
Correct. You can see that 3, 4 is there, 4, 3 should be there. It's
4,
not
3
there.
is not there.
2, 4 is there, 4, 2, everything is there. So here you can see 1, 2 is there, 2, 1 is there. Okay. Let's for example, okay, tell me 1, 1, is this a symmetric relation?
Yes,
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 sir.
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 Is this a
Yes,
Yes.
sir.
reflexive relation?
No,
Yes, sir.
sir.
Yes, sir.
No, sir.
Yes,
Yes,
sir.
sir.
It is reflexive.
Yes,
No,
sir.
how? No, this is not reflexive.
No,
Depends
no,
For
on
no,
the
not.
reflexive,
No,
No,
sir,
it
because
is not
2, 2 is 3,
reflexive.
3 and
3 and
4,
4,
4
okay,
4
is
is
for
not
not
there.
there.
reflexive, that is what I was
It is
trying to
not there.
point it out. For
No, sir. No.
reflexive, there is a condition that for all x means each and every element of x, for each and every
Yes, sir.
element of x, this combination xx should be there. Here,
Yes,
that
sir.
condition is not there. It's just that if xy is there in R, this is my R. If xy is there in R, yx should be there. That's it. Okay, is this clear?
Yes,
Yes,
sir.
sir.
Yes.
Yes,
Okay,
sir.
now tell me whether this relation R4 1 1 2 2 is this symmetric?
Yes, sir.
Yes,
Yes.
sir.
Symmetric.
Sir.
Yes, sir.
Is
Yes, sir.
this
Yes,
Yes,
sir.
sir.
reflexive?
Yes.
No, sir.
No,
No,
sir.
sir.
No,
It
sir.
is
It
not.
is not
No, no.
reflexive.
Okay, what about
Because
this?
3, comma 3,
3, 4.
3, comma 3 and 4,
Yes,
comma
sir.
4
Now
are
It
this
is
not
is
there.
Yes,
reflexive
sir.
and
reflexive or
symmetric both.
symmetric.
Symmetric,
It is
is this
symmetric
is this
both.
symmetric?
Symmetric plus reflexive
Yes,
both.
sir.
Yes, sir.
Okay, okay. I
Yes,
hope
yes.
now you are able to understand it. Let's move to the next part, the transitive, the
Yeah.
last one, and after that we will open for the doubts. And
Mm, yes, sir.
okay, this is the last one. Very simple, transitive. Okay, so here also there is some relation. Our binary relation has been given on S. Okay, so now what you have to check is carefully read it. R is said to be transitive if and only for every pair of element xy and yz, xz should be there. Okay, and that is also condition on R. There is no condition on S. Okay, so there is some relation R. Okay, for this, if xy is present and yz is present, then you should be searching for xz. Okay, if only xy is there, yz is not there, then you don't have to search it for xz. Is this clear for you?
Yes,
Yes,
sir.
sir.
Yes,
Okay.
sir.
Then will it be transitive?
Okay. Let's. Okay.
Yes, sir.
This.
Go little slow on this. No, please.
Okay. Okay. So what I was saying
Okay.
is, you have a relation R6. Okay. Here it has been said that if xy and yz, so there's a condition and, not or. Okay. If xy and yz is present, then you have to search for xz, and xz should be present to make it transitive. If xz is not present and yz is present, then this is not a transitive. Okay, now one example. With the example you'll be able to understand. Let's, for example, S is already 1 2 3 4. Okay, so S cross S Cartesian product you have. Now I have R6 as a relation. Now I have been given 1 comma 2. Is this a transitive relation?
Yeah.
No.
Yes,
Yes,
sir.
sir.
Yes,
Yes,
sir.
no,
Yes,
no.
sir. Yes, sir. Yes, sir.
Yes, sir. It is.
No, no, no.
There
It is
is no
transitive.
It is.
xz
It
now.
It
is.
is a transitive relation.
How?
There is no
Because
xz now.
One is not
Yes,
There
present
is
here,
no
so
no,
we
condition
need.
of YZ.
Okay. Now, so whoever said it is a transitive relation. Totally correct. Okay. Nice that you have understood in one go. But
no,
this.
no, I didn't get it, sir. How it,
Okay, okay,
how
no
it's
problem, no
transitive?
problem. Even I didn't understood in long back when I was studying, so it took time to understand. Okay, so here, see, here it is xy, right? I told you, right? If xy and condition, right? If there is
Hmm.
xy and yz, is there any yz?
No, sir.
No, right?
No,
No,
sir.
sir.
No.
No.
Okay, so if there is no yz, I don't have to search for xz. Okay,
Yes, sir.
Okay, then
Hmm.
XY is our transitive.
Yeah,
If
xy
no
is
YZ is.
transitive. Okay, now I'll give you one more example. So R, I have 1 2, I have 2 1. Is this a transitive?
Yes, sir.
No,
No,
sir.
No, sir.
no.
No, sir. No,
No,
sir.
sir.
One one
Because
should
1,
be
comma
there.
1 is are not there.
No, it is not
Correct.
One
transitive,
should
it's
be there.
symmetric.
Yeah. So for me, this work as a xy. Now I have something yz. So this is yz. Correct. And if so, yz means what? Something that starts with 2 only. That will work as a yz. So I have 1 2. I have 2 1. Xz should be the right. I don't have 1 1, right? If I don't have 1 1, then this is not transitive. Is this a symmetric?
Yes.
Yes, sir.
Yes,
Yes,
sir.
it is symmetric.
Yes, sir.
Yes,
Yes.
sir.
Is
Yes,
this
sir.
a
So, sir,
It is
what if,
symmetric.
Characteristic.
No, sir. It
sir,
is
sir,
not
It's
symmetric.
symmetric.
it is symmetric, sir. It is symmetric.
okay? Okay. What about
Sir, I have one
R1?
doubt.
Yeah, yeah. Go ahead.
What if, sir, 1 2? Sir, write an example. What if 1 2 and 3 4? So it is transitive.
Yeah, this is
Yeah.
transitive.
Yes, it is.
Yes, sir.
See, because this is xy, right? Do I have yz for this?
No, sir.
No.
No, sir.
Now for 3 2, do I have yz? No.
No, sir.
Do I have anything, any other like ordered pair that starts with 4? No. Do I have any ordered pair that starts with 2? No. So I don't have anything. So this is a transitive relation.
Excuse
Okay?
me, sir.
Yeah.
Sir, 1 1 alone will be symmetric and transitive both, right?
That will be
Yes.
symmetric and transitive both. Correct.
The
Okay.
Sir, sir.
Why symmetric?
Why symmetric 1 1, right?
Yes,
xy
yes,
is
yes,
One
sir.
one
y.
can also
Yes,
be
sir.
written as 1 1. So
Yes,
it's the
yes.
same.
So then why it will
Can you repeat how this is transitive? This 1, 2, and 3, 4?
1 2 3 4. Okay.
Yeah, can you explain this again,
Okay.
please?
Okay. Let's read it carefully. We'll try to read it again. R is said to be transitive if and only if every pair of element xy and yz. Let's for example, this is xy. Okay. So for this xy, do I have any other ordered pair that starts with 2 that can work as yz?
No, it's not there.
No, right? So if it's not there, I don't have to search for xz. Correct. Now we'll delete it. This now for this xy, is there any ordered pair that starts with 4?
No, no, no.
No, right?
No,
So I
sir.
don't have to search for xz. So if I don't have to
Yeah,
search,
sir.
that means it's a transitive. Okay.
Sir, can you explain how 1 1 will be transitive? Because there is no xy. It is xs only.
No, xx only, but you can just think
Oh.
of as xy. You just think x equals
Oh.
to y 1, y equals to 1. Then you for you z also will be equals to 1. So xy I have something. Do I have, so 1 1 for 1 1? Do I have anything that starts with 1? I have 1 1. Okay. Now what I have to search? 1 1 only. So 1 1 is there. So it's a transitive. Okay.
Oh, okay, sir. Okay. Yes. It's like assumption.
Not assumption. All the values are there, right? So x equals to 1, y is 1. So for me, xy is there. Yz is also there. Y I can just think of as yz because all are same only. So for me, this also will become xz also. So all are there.
Okay.
Now,
Sir, is it necessary? Just imagine, sir, if I have bunch of order pair, and in that order pair, 3 pairs should be make a transitive relation, but another 2 pair doesn't make any kind of transitive relation. So
even you are
it
able to
will be.
find one pair that doesn't make transitive, okay, then that is not transitive. Even one pair, one even ordered pair doesn't make transitive, right? Let's for example, uh, 1 2 2 3, this is 3 2. Okay, so okay, is this a transitive?
No, sir. I think no.
No, sir.
This is not
One,
transitive because 1 2 you have 2 3 1 3. Okay, let's make
three,
it
one
1
not
3.
present.
Is
Two
this
one is
now a
symmetric.
transitive?
Yes.
No.
This is not a
2 2
transitive.
is not
Again,
there.
see 1 2 for this xy, you have something yz, and for that yz you have xz also. 1 2 2 3 1 3 you have. But so for this three condition, okay, for this 1 2, you are assuming that this relation is a transitive. But now think of this. You have 2 3. So for this xy, you have 3 2 as a yz. So you should be having 2 2, right? That 2 2 is not there. Okay. So even for one pair, you are not able to make the transitive relation, then this whole relation is not a relation, transitive relation. Okay.
Okay, sir. Yes, sir.
Sir, can you explain the equivalence relation?
Equivalence is if
Sir,
it is following all three,
sir,
then it is
instead of
equivalence.
instead
No,
of
in a
these
detail,
two,
like what
if
is a equivalence class and all the things.
sir, yeah, just it is 3 2 and right there 1 and 4. So
Okay,
it
you
will be
just tell
transitive.
me about this all five now. R1, R2,
No,
R3, R4, R5, all are transitive or not?
no, sir. It's just here example you write it now. So here 3 2 is the order pair. Just remove 3 2 and put there 1 and 4. So it will be transitive.
Okay, if I'm putting, what I should be putting?
Sir, 3 2. Sir, just look at sir what you example take. Sir, 3 2 is there,
Okay.
right? Sir, look at 3 2, sir.
Yeah. What
It,
should I do? Like I should I remove
sir,
3, 2 and
yeah, yes, sir. Remove it.
okay, I did remove. Okay.
Okay, put there 1 comma 4.
Okay, 1 comma 4.
So now this relation will be transitive or not?
Transitive.
Yes.
It will be transitive.
I can't.
Now it is transitive, sir.
Because AB, BC, and AC is present here.
It's transitive.
Yeah, this is transitive.
This is transitive now, sir.
Yeah. Yeah,
Okay,
this is
sir.
transitive. 1, 2, 2, 3, 1, 3 is there. 2, 3, there is nothing. 1, 3, there is nothing. Yeah, this is transitive.
Sir, X is not matter. Y only matters.
Yeah. Y means it should be if anything that starts with that ending order pair, right? Let's for example for 1, 2. Is there anything that you have to search that starts with 2? If it's there, then you have to search for X. Okay. It's like I'm a friend of yours and you are friends of someone else, then if I'm his friend or her friend or not. So this is how it works. Okay. So if yeah.
It's
Sir, in
like if
R4,
AB and BC is present, then AC should also be present there to be transitive.
Correct. If AB is present, BC is present, AC must be there. If it's not there for even for one condition, then you can directly remove it. You can tell that this is not a transitive relation. Okay.
sir, I have doubt in R4. I think it's a transitive relation. How do you say it's not a transitive relation?
No,
Can you
I
please
just
explain?
asked everyone else to check. Check for all the 4, 5. R4 you are talking about. For R4,
Sir, can you repeat, sir? Constitution repeat, sir.
repeat what? The transitive. Huh?
Yes, sir.
Okay. So what I was saying is for a transitive relation, right? If you have xy present in a relation, you have to search for yz. Okay. So let's for example 1, 2 is present. Okay. You have to search for ordered pair that starts with 2. Okay. If you are able to get, then what you have to do is you have to check for xz. So let's say example, this was, if I am thinking this as xy, this will work as yz because there are some element that starts with 2. If it's there, then I have to search for xz, okay, that you call. So 1 3 must be there and 1 3 is there. So this is transitive. But now you have to check for other ordered pair also. So here you checked 2 3 is there. So is there anything, any pair that starts with 3? This starts with 1, this starts with 1, nothing, right? Now you just go here 1 4. Is there anything that starts with 4? No, right? So now you'll come here. Is there anything that starts with 3? No. So now you can say that this is a transitive relation. If for any pair xy only is present, right? You don't have to search for, like if for xy yz is not present, like for 1 4, there is no element that starts with 4. So you don't have to worry. You can directly go for the next term. Is this clear? So if you have just 1 2 as a relation, this is a transitive relation because you just have 1, 2. You don't have any other element that starts with 2. So you don't have to search for any other thing. Is this clear now?
Yes.
Yes, sir.
Okay.
Me, sir.
Sir, can you
Yeah.
explain the R4, sir?
So
Because
R4 is transitive, no?
yes, sir.
No, because 2 is not there. 2 is
Yeah,
not
R4
there.
correct.
and
2 is
R5
not
is
there.
not
Even, yeah.
transitive. R1, R2, and R3 is transitive only.
Okay, let's check for R4. Many of you are getting confusion. So for 2, 4, is there anything that starts with 4?
Yes,
Yes,
sir.
sir.
4, 1.
4-1.
Yeah, sir.
Yeah, it's
4-1.
4-1.
So the 4, 1.
Yes,
So
sir.
2, 1 is there, right? 2, 1 is there. Is 2, 1 there? Yeah.
Yes, sir.
Yes,
2-1
sir.
Yes,
is.
sir.
Okay.
Yes, sir. But 4 2
Okay.
is not there. Not there.
4, 2. Why are we searching for 4, 2 now? Okay. So now for 1, 2, is there anything that starts with 2?
Yeah,
Yes,
What
sir.
we
2-1.
Yes, sir.
have?
2, 1,
2-1.
sir.
So
2-1.
1, 1 is
For
there.
that, 1-1 is also present.
Okay. No, but
Yes, sir.
now here 1, 4 is there.
Yes, sir.
1,
Yeah,
4 is
1-4
also
is.
there.
4-1
Okay.
is there.
Okay. So 1, 4 for 1, 4, is there anything that starts with 4?
Yes, sir. That
Yes,
is
sir.
So
4,
4-1.
1.
1, 1 is there. Nice. Okay. Now for 4, 1, anything that starts with 1. So you have here 1, right? So 4, 2 is there.
Yes, sir.
4,
No,
2 is not
no,
there.
sir.
4. No,
No,
sir.
sir.
4-2
No.
4-2 is not.
That's why it's not a transit.
Yes.
Damn, it's very complex.
Mm.
Yes, sir.
Yeah, this was complex, but
So 2 4 is there, so 4 2 is not there, so it would be transitive, no?
what?
2 4 is there.
Order are
For one
different.
condition is met, no?
No.
There is
For a relation, for a transitive, every pair should follow. Okay, even though if you are able to find it for one relation, it is not following. The whole relation is not transitive. Okay.
What my question is, what my confusion is, in the R2, in the third one, the R2 1 4. So we are calling it transitive. Here in the same case, R4, 2 4 is there.
Where? Okay. Wait. Where? In
R2 1 4 we are calling it as a transitive because
that is
1 4 is
transitive.
1 4 is there, 4 1 is not there, so we are not bothered about the other.
Correct.
Similarly, when we are coming to the R4, 2 4 is there. So 4 2 is not there, that's why we are not bothering.
No. We are not bothered about that one
For
because
2,
of
4,
not because
4,
of
1
that.
is there.
See, I was where were we for
4-1.
4 1, right? For this
Yes,
4
sir.
1, for this 4 1, do you have
1 4 is there.
this 4 1, right? And then you have 1 2, correct? So this work as xy, this work as yz. You must be having 4 2. If you don't have 4 2, then this is not a transitive. Are you getting me?
Okay.
You got it right. That
Sir,
is not
but
Yes,
because
got it, sir.
2 4 was there and 4 2 was there. It's not because of that. Because 4 1 was there and 1 2 was there. So I should be having 4 2. Okay?
but for that 4 1, 1 1 is there, sir, and 1 4 is also there, sir.
Yes, sir.
No,
I
okay,
was
that is
asking if
fine.
we can get
4 1 is there, 1 1 is
1
there, so 4 1 is there. That is fine. I don't have any problem. But for this condition, I don't have 4 2, right? Even for one condition, it is not fulfilling. You can directly exclude it from transitive relation. Okay?
Yes, sir. Yes,
are
sir.
we taking, sir, more than one YZ for one XY?
Can you take another example?
Another example. I don't know whether this. Here also there are some examples given. I don't know.
Yeah, it would suffice, I think.
Sir, anti-symmetric, sir, in lectures, sir, IIT Madras professor, they told us like anti-symmetric relation. They told us
Yeah,
anti-symmetric
sir. That
relation,
is
sir.
confusing.
Yeah,
What is
Antisymmetric
that?
anti-symmetric.
relations.
What is
Antisymmetric
anti-symmetric?
relations.
Anti-symmetric.
Yes,
Yes, sir.
sir.
Anti-symmetric is opposite. Okay, there are two, I guess, thing. Anti-symmetric.
Anti,
For
anti.
AB that belongs to a relation R, BA should not belong to that relation.
Yeah. No, sir. A and B is belong to R, and A does not equal to B. Then B belongs to A. Sorry, B and A does not equal to R.
It is opposite of symmetric, isn't it?
No, no,
Yeah,
I think
that's why it is
Anti-symmetric, there is
anti-symmetric.
not a single question in the paper from anti-symmetric.
yeah, that is what I was saying.
But
So
Anti-symmetric
don't
and
bother.
a.
So, but it has
That
been
professor told
mentioned in
us
the classes,
about.
yes, sir.
it
Okay,
is
okay, I can.
mentioned in the class, na?
Okay,
Yeah,
one second. Anti-symmetric and asymmetric. There are something. Okay, anti-symmetric and asymmetric are not same. One of asymmetric, I guess, is opposite of symmetric, but anti-symmetric is not opposite of symmetric. Okay. Mm.
Symmetric is A and B
So I
comma
googled
B.
about it and
AB is
came
the
to know
element of
that
R.
Asymmetric is
anti-symmetric,
opposite of
asymmetric, and
symmetric.
sorry.
Sir, AB is a element of R and BA is a element of R. Then like A should be the A equal to B, sir.
What? I didn't understood.
Sir, I'm taking an example, sir. If, for
Okay,
example,
okay. You try to first solve this example. This came in previous term paper. Okay, try to solve this. By the time I'll check what is anti-symmetric and asymmetric. Okay. So there's a
Okay.
question. There was a question that was asked in one of last term paper itself. So there's a set A, right? And A is a set of all odd positive integers that is less than. So A is what? A belongs to. A is a set of odd positive integers. Okay, those are less than equal to 20. This is the one set. Okay, then you have set B. B is a set of all positive numbers. Yeah, these are set of is the set of all positive number. This is not here, it is odd. Here it is all positive number integers. Those are less than equals to 30 and divisible by 30 plus divisible, and which are divisible by 5. Okay, so I'm just making some relation A to R. So this is the question. I'm making a relation A to R. There is one relation R1 from A to B such that it is written in the form of AB such that A is coming from A and B is coming from B. So this is the ordered pair AB where A is coming from the capital A, small b is capital coming from capital B, and it has said that A is a factor of B. Okay, this is one relation. You can close it. So you can close it. Okay, and the other relation is R2. It was also same in ordered pair of AB such that A belongs to capital A, B belongs to capital B, and where it was given like A plus B mod 15 is equals to 0. Now you have to tell me whether R1 is transitive or not. What do you have to tell me? Tell me about R1. R1. Okay.
So can you explain the question once?
The
Okay. The
factor
question
is
is
like divisible by B. Like
A is a set of all the odd positive number less than 20. So that will be 1, 3, 5. Okay. B is a set of all positive number less than 30, which are divisible by 5. Okay. So you can just think of as 5, 10, whatever number. Okay. Now you have to tell me there is one relation R1. Okay. R1 is a ordered pair of AB. Okay. So A first number is coming from capital A set, second number for ordered pair is coming. So you write a relation, right, in a ordered pair, correct? So you write a relation something like that, right? R1 equals to AB, right? Where A is coming from capital A, B is coming from capital B. And what is the condition that has been given? A is a factor of B. Okay. And then R2 relation is, so this is R1 relation. You have to tell me R1 is what? Is R1 a transitive relation or not? So
Sir,
you have to tell me, is
R1
R1 a
would be like
transitive
A
relation?
comma B in in place of A comma B, it will be like 1 comma 3 like that, sir.
Correct.
Like a 5, just for example, 5, 10.
1 comma
Like
2, then 1
Yeah,
comma
it is
3, 1
transitive.
comma 5 like that.
Yes, sir, it
Yes,
is
sir.
transitive.
And then you have to tell me whether R2 is a transitive or not. R2 is symmetric or not. You have to tell me.
Symmetric or not, or transitive or not?
Hmm.
Symmetric or transitive? For what do we search?
Search for symmetric.
But it is
Okay,
not
sir.
symmetric, sir.
No, first of all,
No.
A plus B.
R2 is symmetric
Yes, sir.
because
Is it
A plus
symmetric?
B mod 15 equal to 0 means same like B plus A mod 15 equal to 0.
yeah, A plus B or B plus A, both.
B should be positive integers like this. B.
Yes, sir, it will be symmetric. 15, comma 15.
Yes, sir.
R2 is symmetric, sir.
First, how many of you are able to write R1 and R2?
Sir, me, sir. R1 is your 10, comma 5, and am I right? Sir, A is factor of B. That means,
How
sir, B is
can
divisible.
the first
B divisible
value
by
be
A.
10?
5, comma
A
5,
should be 10
5,
now.
comma 10,
15, comma 5 and
5,
15,
15, 15, 15, 5, 20.
It
Why
is
have we
5,
don't
comma
take
10, 5,
5,
comma 25.
5, comma 5 is also there, no?
But 5,
Yes,
comma
5,
5 mod 15 is not 0 now.
No, A is a factor of B. R1, I'm talking about R1.
Sir, is there any
Oh,
smart way to find A plus B mod 15 equal to 0 like?
What?
Is there any smart way to find A plus B mod 15 equal to 0 like less
No,
time?
there's no smart way. You have to write
You have to
first
find
of all.
manually, sir.
No, all the element of R1 and all the element of R2 first you have to write. First to write A, B. Okay, and then you have to write R1 and R2. If you are able to write R1 and R2, then I don't think so there will be any problem.
Yeah.
बंद कर लो.
Sir, will B start from 5 or 1?
Okay,
Will
let's write.
A plus B can't be.
Okay,
Will
just
B
tell
start
me.
from 5 or
Can
1?
some of you just tell me what is the R1?
A 1, plus 3, 5, 7,
So
9.
5.
Yes,
What?
R1 is
5?
1 comma 5, 1 comma
5,
10,
5.
1 comma 15, 1 comma
So
20, 1
there is a
comma
doubt.
25, 1 comma
Yeah,
30, 3 comma 15, 3 comma 30, 5 comma 5, 5 comma 10, 5 comma
nice.
15,
That is
5
correct.
comma 20,
Correct. Yeah,
5
that
comma
is correct.
25, up to
R1 can
15
be
comma
1 to
15.
15 also, right?
Yeah, that's correct. What
Then
about
R2 is
R2?
5 comma 10, 5 comma 25, 15 comma 15, 15 comma 30. There is only 4 pair in R2.
That is also correct. Yeah. Now, how many of you are having difficulty in writing R2?
Sir, I have difficulty. Can you write it?
It's taking a lot of time.
There is no
Finding
A
R2.
plus B which added to 30, I think.
But you don't have to. Okay. In that way. Huh?
A plus B,
There will be, right? 5 plus 25.
but it's odd and even number, sir.
Odd
A
and
is
even.
all odd and
No,
B is odd even.
this is not odd and even, right? For B, there's nothing.
Positive.
It's just be positive. Yeah, to get the summation as that is.
So I think R2 is not transitive.
Okay, R1. Sorry, leave R1. What is A? And what is B?
1, 3, 5,
A is
7,
1,
9,
3,
11.
5.
A is 1,
1,
3,
3,
5,
5,
7.
7, 9,
5,
11,
7,
13,
9,
15,
11.
17, and 19.
1 to 19 all odd numbers.
Correct. What is B?
5 to 30 all divisible by
5,
5.
10,
5
15,
Multiple
20,
of
25,
5.
30.
5, 10,
30.
50. Yeah.
20, 25,
Okay.
30.
What do you need for R2? You need R2 such that the summation should be divisible by 15. Correct?
Yes,
Yeah.
sir. Yeah.
Okay. Now
R2
if
is
you are
5,
yeah.
10, 5,
Hmm.
5, 15, 15, 15, or 15, 30.
Okay. Correct. If you are taking 1, you can't take anything from here, right? From B. So you have to take something, like you have to think in such a way that you have to, it should be multiple of 15, right? Correct? So if you're taking 5, you can take 10 from here, right?
Hmm.
5 comma 10. What can be the next
Yeah.
number?
5,
5,
5,
25.
25.
5,
Yeah, correct.
25.
5 comma 25. Correct. What can be the next number that you can take it from here?
15,
Then
15.
15,
10,
15.
5.
15 comma
10, 5.
15.
Sir,
And
why
15,
10,
15.
15, sir? Sir, 10, 15.
10
10
is
is
not
not
there
there
in
in
the
10,
any.
set
common
K,
5.
na?
Sorry.
Yeah, yeah.
Okay. What about next number?
15, 30.
It is 15 and 30.
Yeah.
Correct. And what did I ask for R2? Did I ask symmetric or what did I ask?
For
Symmetric.
symmetric.
Transitive relation.
This is not
Both.
symmetric, right? This is not symmetric.
Yeah.
Okay.
Yes, sir. This is not symmetric.
It's only a transitive relation.
We can talk. Okay. Now R1 you can write it, right? You can solve it.
Yes, sir.
Can you show the R2 set?
R2 set, yeah.
So it is not transitive, right?
No, this is not transit. I asked about symmetricity.
But
Okay.
which one? R1 or R2?
R2. R1 I asked transitivity, right? R1 is transitive, I guess.
Yes, sir. Yes,
So
sir.
you can just think of solve it, okay, as a homework.
Can you draw R1, sir?
Sir, R1 is the transitive, but not symmetric.
What?
Sir,
R1 is transitive.
what is the like mean of A is a factor of B? That means B is divisible by A.
Correct. This.
So I took like B is firstly now, sir. First pair
You can
it
write it
will
as
be.
A divides B to make it simple. Now you can get it right.
So A divide B, sir. Then A is smaller, like 5 divide 10, as like that way.
You can write 1 5 can be one thing. 5 5 110 115. Call combination with 1 you write first. Then you can
Sir,
write.
it says
I
that
have
A is a
confusion.
factor of B. Then we can write 15 comma 5 also, na?
You can write
No.
15 comma
Comma
5.
5. Because 15 is in the A set and 5 is in the B set. And 15 is a factor of 5 somehow.
15 divides 5,
15
right?
is
That doesn't happen,
multiple.
right?
15 is a multiple of 5.
You can just think of as A divides B, something that divides B. 15 doesn't divide 5, right?
Yeah, but it somehow there's a factor. So that's why I think so.
A is a factor of B, so A should be, just think of as A something smaller, okay? And B something bigger.
Okay, sir.
Now A divides B, or you can just think of as B divided by A, something like that you can think. A is a factor, right? So 24 ka factor, what do you mean by a factor of 24? So what are the factors of 24? As an example, I'm just telling you. You can just think of as 1, 2, 3, 8, something, right? Those are all lesser than B, correct? Those are not bigger than B, right?
Yes, sir.
So I hope
Sir,
now you
sir,
can
sir.
write.
Sir.
Yeah.
Sir, it will be like in that way, 1 comma 5 and 1 comma 10, 1 comma 15, 1 comma 20, 1 comma 25, as like that way.
All those combination will be there, correct?
Yeah. And we move to 5s, then 5 comma 5, 5 comma 10, 5 comma 15, all the multiple of 5. till
Even
30.
with 3
Then
also you can write 3, 15 will be
yes, sir,
there,
3
right?
comma
3,
15.
30, those
Yeah,
combinations.
yeah, sir.
A
And
good chunk of number. But how did somebody told very fastly, like how did you know that that will be transitive? So many people said, right, in a one go. How did you thought?
Sir, is it,
Sir, because
are you asking R2?
No, R1, R1.
R1 is not transitive, sir. Actually, there is no relation in none of the relation in that R1.
No, R1 is transitive. Then you're
sir, R1 is
Trans-
transitive, sir.
R1 is transitive, right?
Because for example, if you take 5, 10 is a element of R1, like, and 10, 20, we can see that R1 element of R1. So since
Sir,
5 is a factor of 20.
See, R1 you can just think of in that way, right? See, R1 you were taking, right? R1 was something, was what? The first element was a factor of, like A was a factor of B, something like that. So just think of in that way. If you're writing 1, 5, or you're writing 1, 10 or something, you're writing, okay? So if you're writing in this 1, 5 and all, so you'll be having something called 5. If let's say example you're taking 5 now, so 5 comma 5 will be there, right? So 1 comma 5 for sure will be there, right? Or you take it as starts with 5, 15. So 115 for sure will be there, right? Are you getting me?
yes, sir, but
yeah.
one doubt here only. 1 comma 10 is there, but there is no 10. Okay, sir. Thank
That
you.
transitive doesn't mean like you should not be
Yes,
having
yes,
anything.
X
Yeah,
comma Y is there. There is no Y comma Z, so it's a
correct,
10.
correct.
Okay, sir. Okay, thank you.
How many of you have understood this and like you are able so this type of problem will be coming in the exam. This is one example that we discussed. Okay.
So
You
I
can.
have
Yeah.
so I have understood everything, but only how to identify whether it is a function or not, that part I have not understood from the whole session.
Okay, so here it is the function. We'll discuss about the function. So function is nothing but function is sum of, like you have a n number of relation, right? So you have x, you have y, right? You can have different type of relation between x and y. But out of those relation, there are very few. Those are functions also. Which are those functions? So it just says that function is a relation in which each element of x, if the mapping from x to y happens uniquely, like uniquely means if you are mapping from x, so here it is x, right? So you are mapping 1 to b, right? Or 2 to c or 3 to a. So can you see any mapping that happens from x? Are there two arrow coming out from one input? No, right? That is what is said.
Mm.
From each element in set x is mapped with exactly one element. Okay, if that is happening, then those type of relations are function. Okay, if you are not able to understand now itself, I'll tell you. See, there is some function, right? There is some function. In that function you put some input and then you get some output, correct?
Yes, sir.
Correct. Now, if in a function you put some input, but the output you are not able to know. So there are some 3, 4 outputs you are getting. That can't be a function, right? If you are putting one input, you should be getting one output. You can't get more than one output. Okay, those type of relation are not function. That is what happens here also. You can see that this is a function, this is not a function. Why this is not a function? Because you can see that when we are putting 3, 3 has a output a and 3 has output d also. That can't happen. That should not happen for a function. Okay, if you are putting one input, one output should come out. Is this clear?
Sir, it is many one function, I think.
No, many one and all you don't have to read now. I'll tell you about those. First, you have to understand whether this is a function or not. Then in function, you have to understand many one and one and all. Okay. Many
Sir,
one
as
is
per the diagram, sir.
Yeah.
Sir, as per the diagram, sir, the x should be unique. But why should be like, for example,
It's
output
the
is
the
like,
mapping should be unique. Okay. So mapping unique means, see, I'll tell you maybe 1 second.
because C is coming from like 2 also and 4 also.
Okay, there's 1, there's 2. Okay, this is A, B, right? Okay, there's 1, 2,
The
3, 4.
pre-image value should be unique, isn't
Correct,
it?
correct. Yeah. So this is A, This is A, B, C, D, E, F. You can map it like that. A, you can map it to A. 2, you can map it to B. 3, you can map it to A. That is totally fine, because in a function when you are putting F3, you are getting A as a output. One output you are getting. Okay, uniqueness, and I'll leave it uniqueness. If you are putting 3, you are getting. If you are putting 1, you are getting A. This A are same, but see, when you are putting F of 3, you are getting one output, right? You are not getting two output. Are you getting me?
Sir, one input produce one outputs. It's right, sir?
Correct. So one input should not give many output. Okay, those are not function. Those relation are not function. If you are getting
So
multiple
one
output.
cannot be mapped to A and C. It can be mapped to only one on the
Correct.
side.
Yeah.
Okay.
3 can be mapped to A. 1 can be mapped to A. That's totally fine. But one can't be mapped to A also, one can't be mapped to B also. Okay, because it's pretty simple, right? If you are a function, if you are putting some input, you should be getting only one output, right? You can't get two output.
Yes,
Then
sir,
it will get
understood.
confused, right? It will get confused, what should I give as output. Here if I'm putting 1, I'm pretty sure that output I'll be getting A. Okay, so this is okay. Now tell me, this is a function or not? Is this a function?
No.
No,
No.
the
No,
first
sir.
element is appearing twice.
Yeah, it's
Correct,
a function.
because 4 can't give two output, right? Okay, now you have dealt about function. So now in a function there are some terms. Okay, there's something called domain. Okay, so
So,
domain is, yeah.
Sir,
so one more question. If 4 was mapped to D or E, whatever, and 5 was not mapped to anything, then is this a function?
Okay, so if you'll go into that detail now, then also it's not a function. But yeah, as of now, you can just think of that relation as a function. But see, that will not be in a domain itself. So okay, that is a different thing. As of now, you can just think of as 4 element, all 4 was mapped to something. Okay, if there's some vacancy, okay, that it again is a problematic thing, but because that itself is not in a domain. So if a function, if you are defining some function, right? So if, because this A is a domain for a function, if you are defining this as a function, so there can't be any vacancy, there can't be anything that is not mapped to something, then you have to remove this 5, because that doesn't come in the domain. And if that is nothing, that is something that is not in the domain of a function. So okay, let me define first domain. What is the domain of a function?
X values, all the X.
Those are the values, yeah, domain of a function. So there are some values that you can put in the function, and the function will be defined. Okay, you'll get some output out of there. Okay, those are the input values. So domains are the input value that you put in a function and you get some output. So if this is a function, so these are the X value. What are the X values where the function will give you some output? Okay, those are the domain of a function. Okay, so if you are defining a function from set A to B, so this is A is a domain of a function. Okay, if you are defining A is a domain, that means what? For each of the input there must be some output, correct? Otherwise, if there is something 6, this is not mapped, that means what? At 6 the function is not defined, so that doesn't come in the domain of that function. Is this clear to everyone?
Yes,
Yes.
sir.
Yes, sir.
Yes, sir.
Yes, sir.
The domain is clear, right?
yes,
Okay,
sir.
yeah.
Yes, sir.
And there is something called codomain of a function. If you're not able to understand it, we'll again repeat this maybe after your quiz one. But as of now, you should be knowing a basic stuff. Okay, the domain is something, okay, that you, those are the values of x, that those are the input values of x at which the function is defined. Codomain is the expected output that a function can give. Okay, this is codomain.
B.
Here, yeah, B is the
Yes, sir.
codomain. Here there can be something that is
It's
not mapped. So
possible.
from here 5, let's for example E is mapped. There can be some places in the B that can be vacant. Okay, these are the expected output, and the actual output is the range of a function. Okay, there are three things that I told you. One is the domain. Domain are all those inputs at which the function is defined. Okay, if you are doing the mapping from A to B, for sure all from A there should be some mapping to the B. Okay, B is the expected output, the output that a function can give. Okay, and the range is the actual output that a function gives at all its range, all its domain. Is this clear to everyone?
Sir, what
Yes.
will be the example of range? Means this A, B, D, E, and F are the range.
Correct. A, B, D, E is the range for this function.
Okay, and the codomain is
A, B, C, D, E, F.
yes.
Expected output. Okay.
Yes, sir.
And the domain is 1, 2, 3, 4, 5. Okay. Is this clear to everyone?
Yes,
Yeah.
sir.
Yes, sir.
Yes, sir.
Okay. If this is clear, and now somebody was talking about one input, one output, all those things. See, there is something, there are some different type of functions also: injective function, surjective function, and bijective function. Okay. See, there is something called injective function. What do you mean by injective function? Each element in X is mapped to distinct element. Okay. So I was talking about something. This is also let's say example. This is a function 1, 2, 3, 4. A, B, C, D. Okay. Earlier it was 1, 2, 3 was also mapped to C, and D was also mapped to C. So here each element of X is not mapped to distinct element, right? You can see that 3 is mapped to C and 4 is also mapped to D, C only, correct? Are you getting me?
Yes, sir.
Yes, sir.
So this is not injective, right? For injective, what should happen? So 4 should be mapped to D. Okay. Each element should be mapped to distinct element. Okay. That is what is one function. Okay. Or injective function. Is this clear to everyone? See, this all thing you can understand it by one. See, if you have to calculate the inverse of a function, right? I told you for a function to happen, one input you should be getting one exact output. Now you take the inverse of this function. If you will take the inverse of this function, that means what? If you are taking the inverse, that means if you will put this value, you should be getting this output, right? So to be an injective function, so earlier I told you, right? Earlier the mapping was something like that. So 4 was also mapped to C. Now if I'll calculate the inverse, right? If I'll put this, for example, G inverse of C, what will I get? Can you tell me? If I'll put C here, I calculated the inverse of this function and I put C here. What will I get?
3, 4.
Uh,
3,
it is
Sir, it
injective.
will not
Two
be
answers,
function,
so
sir.
it's not a function.
Correct. So the inverse is not a function, right? Correct. So those should not occur. So that means what? This is not a one function. Okay. Is this clear?
Yes,
If
Yes,
the
sir.
sir.
inverse doesn't occur, right, for any function, the inverse you are not able to get the inverse, then those are not the injective or the one function. Okay. So that means what? If you are putting x1, right, at x1, if you are getting fx1, at x2 you are getting fx2. If both are equal, that should only occur when x1 is equals to x2. There should not be any other point where fx1 is equals to fx2 and x1 and x2 are different. Is this clear to you?
Yes, sir.
Yes, sir.
Yes, sir.
To everyone?
Yes, sir.
Yes.
Yes, sir.
Yes, sir.
Here the horizontal line test that I was talking about, that works. Okay, at one point you should be having only one output. And surjective function is nothing when your range and codomain. So is this function a surjective function that I was talking about?
No, sir.
No.
Sorry
This
to
is
take
not
you back.
mapping.
You mean to
Yeah.
say the vertical line in the map or the horizontal line you were mentioning now?
Yeah. So vertical line, I told you, right? Vertical line was to check whether the given mapping is a function or not. Okay. And the horizontal line test is for checking whether the function has an inverse function or not. Okay.
Can you just show it quickly, please, if you don't mind? I think we missed
Okay.
it.
Okay. So what I was talking about. So let's, for example, you have a function, not function, a mapping has been given, right? This is a parabola, okay? Y square equals to 4x. Okay. This is a parabola. Now, if you have been asked whether this is a function or not, how will you check?
Vertical line test.
If
Vertical.
horizontal,
Vertical.
one
Vertical
point.
line
Vertical.
test you will check, and you can see that this is, yeah, at 2 point at 1 x1 you are getting y1 and this also y2. Okay, so fx1 is giving you y1 also, y2 also. So it's like you don't know what will I get. So this is not a function. Okay.
Yes,
Now
sir.
think of any function like this. Okay. Now, if you draw a horizontal line here, okay, this is cutting at two places, right? That means what? I told you, right? This is x1, this is x2. At x1, you are getting something fx1, and x2, you are getting fx2. Both are equal. Fx1 is equals to fx2.
So,
Correct? But is x1 equals to x2? It's not, right?
No, sir.
no.
No, sir.
Okay. To be a 1 1 function, what condition I told you? If fx1 is equals to fx2, it can happen only if x1 is equals to x2. But here it is not following, right? So that's why this function is not injective or 1 1 function. Okay. Clear?
Yes, sir.
Sir, can
Yeah,
you
thank
repeat
you.
once again, sir? I have not understood this.
Sir, in above diagram, if you will draw a horizontal line, then it will not cut 2 points.
It is
So,
cutting, right? It is cutting 2 point, right? This is horizontal
no,
line.
no, not this.
Sir, can you
The
repeat, please?
diagram above this.
This is
Yes,
not
sir.
even a function. This is not a function. Not a function.
Okay, so first we have to check whether it is a function and then you have to draw the horizontal line.
Correct. If it is not a function, then there is no point of checking anything else. Okay, so somebody was asking. I was okay. So let's say example. There's a function something like this mod x. Correct. Mod x is there. Okay. So here also this is not passing horizontal line test. That means what? At if I'll put x equals to 2, or if I'll put x equals to -2, what will I get as a output? 2.
2.
2 only.
Correct. But is so what I said is, if I'm getting at
Sorry,
2
actually, we are
or
not understanding this. 2 and -2 and why only 2?
Mod function always gives positive answer. Mod function.
yeah, y
Okay.
equals to mod x, right? So if we'll put x equals to 2 or x equals to -2, it will give you the positive output only. Okay. Is
Sir,
this
will you
clear?
proceed the class? Because the time is lagging. That's why I'm asking.
Okay, so if so see, this is 1 1 function, right? This is not 1 1 because again you can see that, right? At 2 or at -2, you are getting the output as some 2. Okay. 2 are equal. So this is f of -2 and f of 2. F of -2 and f of 2 are same, but 2 is not equals to -2. That's why this can't be a 1 1 function. If you're not able to understand it, okay, one simple thing I can tell you that can be a simplest that I was telling you in the starting about, you have been given two sets, set A and B. You have some value 1 2 3 4 5. You have A B C D E. To check whether the function is 1 1 or not. Okay. I told you, right? One input, exactly one output. Okay. So 1 ka 2 3 4 5, and here it's f also. This is a 1 1 function because you just think of as there is one function, this is fx, right? This is fx in this direction. So in this direction it must be f inverse x. Correct.
Yes, sir.
Yes, sir.
Yes, sir.
Correct. Now for f inverse x, if I am putting a, what will I get as output? If I am putting a, what will I get output?
1.
1.
1. Correct. Okay. Now I'm changing this. What I'm trying to do is, for 5 also the output is d. Now if I'll put f inverse d, what will I get as output?
4 and 5.
Not
4 and
Not
5. I can
possible.
get 4
4.
or 5.
Son.
Correct. Right. But for a 1 1 function, what should I get? Only one output, right?
One output.
So this is not a 1 1 function. So I hope you understood, right? So if
Yes.
Yes,
one
sir.
mapping,
Yes,
yeah,
sir.
I hope this is clear, right? So in this way, this is 1 1 function. And if you have to know about the surjective function, surjective is simple. Anybody knows what do you mean by surjective function? It's just that the
Range is
range and the
equal to
codomain should be
codomain.
correct, correct. So if this was the mapping for a function, so here you can see that I told you, right? This is codomain, this is domain, And what is the range for this function? The range and the codomain is same, right?
Yes.
Codomain is the expected output. And what is the exact output that you are getting for this function? ABCD only, right? So codomain is what? ABCD only.
ABCD.
And what is the range? Range is also ABCD. So whenever the range and codomain are same, you call it as a surjective function. Okay, and when the function is both surjective and one, you call it as a bijective function.
Bijective.
Is this clear to everyone?
By any
Yes.
chance, we are going to cover any portion of week 1 in next session? Because
What is
it
left
might.
in week 1 now?
Okay.
I just had a
If we
doubt
can
about
repeat
that
functions again, it will be of and revise the
Yeah,
relations.
because
It will be of help
it's
because I
getting
think we went
overwhelming
really
now.
fast.
So
Okay, we'll revise it relation and function again in the next session with some
yeah,
examples. Okay.
because now
Okay.
I think we wasted a lot of time in the beginning of the class.
Okay, no issues. We have enough, a lot of time. Next session tomorrow we have a session, right? So we'll discuss again.
Excuse me, sir.
Okay, so
Yeah.
Sir, I have a doubt in the frequently asked question you made us do in R1.
And what will be the timing of the tomorrow session?
Same 8 to 10. Huh? Frequently asked question. Huh? Where is that?
Sir, can you share PDF?
Yeah, I'll share all the PDF that I have.
where can I get the PDFs?
Yeah, I'll share you, and mostly I'll be mailing all the PDFs. I'll upload on a drive, and drive link I'll mail.
Okay.
Yeah.
Okay, sure. Thank you.
Okay. What somebody is asking some doubts, you can just ask whatever doubt that you
Yes,
have.
sir. It was in the question you made us do. Set of odd positive integers less than equal to 20, that one.
Okay, this question. Okay. Yeah. What is the doubt?
So, sir, in R1, will we have 15,5?
15,5. No, 15 doesn't divide 5, right? So you have to. So R1 is like A is a factor of B. So B should be some bigger number, right? See, I'm
Because
telling.
in the
Okay, can you just tell me the factor of 15? What are the factor of 15? Can a factor of 15 be greater than 15?
One.
yes, sir.
No, can a factor of 15 be
No,
greater
sir.
than 15?
No, sir.
No,
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 sir.
sir. No,
No.
sir. No,
No,
sir.
sir.
No, right? So A is a factor of B, right? So A will always be small, right? Are you getting me?
Sir, are you going to take
Sir, could you
tomorrow's TA
explain it
session?
again?
What?
Sir, are you going to take tomorrow's TA session at 4 p.m.?
TA session though. TA Manish will be taking the TA session 4 to 6.
So there is no sessions of you tomorrow, I think.
Tomorrow I have, right? 8 to 10.
8
Tomorrow is
p.m.
Sunday,
there
right?
is something week 1 open session is written here.
That session only.
Okay, sir.
We'll summarize, then I'll be taking some doubts.
Okay.
Yeah, okay. This question, anybody has any doubt in this? You can just let me know.
No, sir.
Sir, only 15, 15 will be there, right?
Yeah, 15, 15 can be there because 15 is a factor of 15, right?
And 15, 30 won't be there.
15, 30 also can be there, right? 30,
Okay, sir.
50, yeah, 50. Because 15 is a factor of 30 also. Yeah.
Okay,
Sir,
sir.
Sir, but
sir, can you just
sir, but
tell me the difference between codomain and range?
Codomain and range, right? Codomain is the expected output that a function can give. So it's like, okay, if you are getting confused with that, uh, see this function, right? For this function, what is the codomain? A, B, C, D, E, F.
It's
All.
A.
Set B.
Okay, set B is the codomain. You can just think of in that way. Okay, mostly the function. Let's for example, it is written some R to R, right? So it's like this is input, this is output. Okay, this is codomain, this is domain for a function. Okay, if function is written like this, right? So in the defined function itself, it will be written. This is a code. This is a domain, and this is a codomain. So input, output, expected output, but actual output that you are getting is the range. Later, you will come to know that codomain was nothing. Like it was just nothing. Like, but here you have to read it. Okay, if you have been asked what is the codomain for a given set A and set B is always the if it is a that relation is a function. Set B is always your codomain. But the expected output. So what will be the expected output here? A, B, what is that? A, B, D, E. That is the range. Okay, that's the range of a function. So this is how it will be asked. Nothing very complex will be asked in the paper. Huh?
Sir, I want to ask you something off.
Practice assignment question number 9.
Okay, that we can discuss tomorrow. Huh?
Sir, in the video lectures.
So practice. Yeah. Go ahead.
Yeah, sir. In the video lecture, as you told, equivalence relation is a combination of reflexive, symmetric, and transitive. In the video lectures, sir is also professor also explained that equivalence relation is a kind of partition of a set, and there are like equivalence classes. So can you explain that as well?
Oh, that maybe we can discuss it tomorrow. So whatever is remaining, we'll be discussing tomorrow. If you have anything that you have, whatever we have discussed, the anti-symmetric, asymmetric, everything, whatever the remaining portion, I'll be discussing tomorrow. Whatever we have discussed today, if you have any doubt, you can just let me know. We can discuss it. Huh?
Okay, sir. And sir, this is are you gonna share this AQ PDF, right?
This PDF, if
sir,
you
I
want,
have,
I can give it to you. You can have a printout and then
sir,
try
can
to
you
solve
give me
it.
your mail ID? Sir, can you give me your mail ID? I will text there and you can share with me. Or sir, if you like, can we make some kind of community on WhatsApp and you
No,
will be
WhatsApp
there,
and
sir?
also it's not at all. But I'll try say, texting, not texting. I'll mail the files that I have. Okay, I'll mail it. Huh?
Okay, sir, sir,
Sir,
just give
is
me your
there
mail
any
ID, sir.
peer community
If
in
you,
this batch?
sir,
In this
yeah,
course?
mail ID, sir.
Mail ID I can just write it here, but do not
Yes.
spam it there.
No, sir. Due to respect, like if any hall, like something important, then I will mail you, sir. And all guys will mail you if something will be important. Not for not for spamming purpose.
Sir, is there
Yes.
any time limit in graded assignment? Like test?
Yeah, 18th, 18th February.
It
What?
Week one assignment.
Sir,
Yeah. Go ahead.
is there any time limit in attempting graded assignments?
Yeah.
Sir,
18th
mail
is
is
the
not
deadline,
visible.
right?
Sir,
Only
you didn't
deadline.
write.
18th is the deadline.
Okay, sir. Okay.
But
Sir,
sir, have
Thank you for
one
your
problem.
sir, I have one doubt, sir. It's kind of off the topic. So as we are like, sets kind of, we can relate to a sequel, right? How sequel joins operate, right? So suppose in a set, you say that, like I cannot write like in a set, more than, I have to write a unique value, not like one value repeatedly. But in SQL join, like if I write one, it will be treated as different. But why is it so? Like suppose I make a join of a table. Suppose there are two ones and two twos. It will give me four total rows. But in set it will be only a one relationship. Why is it so?
Okay. In which type of joint you are talking about?
Any join, left outer join, cross join, any join.
Okay. So can you just repeat it? In a joint, what
Suppose
happens?
suppose there is a set have only one element, uh, one. Okay, it will be like summarized to only one element, one. And another set is B, which have two. It would be ultimately it would be only two. Okay, so there is one element. So I will have only one relationship, one comma two. But in case of if I put it in a table way, like suppose in a table I have two rows, one, and another table I have
Okay, I
two.
got it. Okay. So
Yeah.
see.
So I will have four rows, one, two, one, two, one. Like why is
See,
this?
there, whenever you're working, I guess SQL and all you are talking about. So there, let's for example, that is not. See, let's think of as an example. Okay, somebody like earning some salary. Okay, the salary for a two-person can be same, right? And those can be totally different person. Okay, this those data entry that has been done for a two-person, the numbers can be same for those two-person, right? But those can come out from a two different person, right? Maybe I and you might earn the same money, right? Maybe the data entry whenever it was done, the name was not there, but let's say example the salary that came out to be, both can be same, right? So there it will always be taking a two different things. Okay, if you want to remove the repeated version, you can remove it there also, but mostly as by default it will take two different entry. Okay, it can't take one entry itself. Here what we are discussing about is something totally different what you are talking about. Okay,
Yeah, got it, got it.
yeah, you got it right. So the entry that has done can be, the number can be same, so there can be like half of the population are male. That doesn't mean like all is merged and then you just have a two people, male and female, right? It can't happen like, it doesn't happen like that, right?
Got it, got it.
You got it right. So anything else anybody has, or else we'll
Yeah,
go.
sir, I
We
have
will
two doubts.
discuss
First,
our practice
first
assignment by
doubt,
tomorrow, right?
Yeah, we'll discuss it tomorrow.
Okay, okay.
what is the time, sir? What is the time?
8 to 10 again we'll meet and we'll try to, we'll start at sharp 8. Okay, tomorrow we'll not
Okay,
Sir,
so,
when,
so
when
this is our first class, maths one. No? I think
yeah,
this is
this
our
is
first
our
class.
first. Yeah.
Okay, sir, where we will get access all of those classes like CT and stats? In my
All
calendar, it will not visible.
videos is there on the YouTube. You can find it there on
No,
the
I am
IIT
talking
Madras
about this live
official
session.
channel itself. Even though the
Uh,
seat that has been shared right by the TAs, that will also contain uh, the YouTube link of all the videos that we are doing. Okay, so I'll keep
okay.
on asking him to update the link for this YouTube videos also. Okay, so that you can get it all at a one place. The slide that we have used, that will be forwarded to you by Monday. Okay, because operational team doesn't work on Sunday, so
That
I'll forward
sheet,
it to
where
them.
is it available? Containing all the links.
That has been shared by the TA. If you didn't get it, maybe somebody shared also in this like during the session. If you have like didn't got it, then maybe tomorrow if the TA session is there, I'll ask him to share it again. So in the
Okay.
starting some 5 6 session,
Because
he'll
what
keep
is
on.
happening is my calendar has all the schedule, but a very different timing. They're at 10:30, 12:30, and 2:30. So I've been missing a lot of classes thinking
No.
nobody is
Tomorrow you
joining.
have two math session, one from 4 to 6 and one from 8 to 10.
Yes, that I've
So
got to know through YouTube live sessions I was trying to follow. Then I got to know about
okay,
today's
you what you
class.
can do is you can save at least the Gmeet link and the Zoom link. Okay,
Okay.
timing I can tell you 8 to 10. It happens on Saturday, Sunday, and Tuesday. Okay,
Okay.
and the 4 to 6 session that happens on the Google Meet. Okay, that happens on Sunday, Tuesday, Wednesday, and Saturday. Okay, so you can
1 minute. So that happens as
But
Sunday,
sir, in
Saturday, Tuesday,
Mhm.
and Wednesday is
four
the
to
TA
six.
session.
Yeah, 4 to 6, and you can save the Google Gmeet link. Okay,
Okay.
and the Zoom session happens on, that will be taken by mostly me and Avilasa. So that will be happening Sunday, Tuesday, and Saturday. Okay, 8 to 10. That will be a Zoom session. Okay, because then more number of. Okay,
Okay. Thank you.
yeah.
Thank you.
and
Thanks.
where will you get this AQ PDF?
Yeah, somebody has shared that G sheet, so you can just refer
I don't
that.
know.
Okay.
I am talking about the AQ sheet, like AQ PDF you
AQ
have.
sheet. Okay, are you guys there on the discourse?
Yeah,
Yes, sir.
I'm.
Yes, sir. Yes, sir.
Yes, so.
Okay, you can
Only
just
the
check the
students who have come
discourse.
through JE main discourse access, not for the other ones who are
Okay,
coming through
so for
qualification.
those people who are able to check the discourse, I'll upload it on the discourse. For the people who
Discourse is
doesn't have
what,
the mail
sir?
IDs as
Can
of
you,
now, I'll try to send it to the operational team. They will send it to via mail
sir,
itself. So you'll
discourse is
get some
what,
mail.
sir?
Yeah.
I'm not aware about it, sir. Discourse is what? Discord. You are talking about Discord or discourse?
No, there is something discussion forum where people ask their doubts and some of your friends generally
Okay.
sort the doubts. If they are not able to, then it comes to us and then we try to sort it out. So there's something discussion forum where people can post their doubts and then generally people solve it out there. Okay.
Okay, sir, got it.
So there's a
Sir,
channel like
my calendar is very different, sir. It doesn't show me like it show me only like it doesn't mention any classes like it show me only like 15 like it doesn't show me any kind of timing, sir. How to get time and how to get another classes, sir. How to access another I mean how to get another classes like city and stat. I think or like as like you sir, some like somehow different teacher will be teach me city stats and English or
Yeah,
See,
yeah.
you go to the calendar. In left
hmm?
bottom down, there is an option to add to the calendar. So go to the each subject in week 0, access to your calendar. Go to the left bottom corner where you can add the calendar. Keep adding for all the 4 subjects. So you will be able to see a collaborative calendar in your Google first
In week
page itself.
zero.
Yeah, in week 0, go there.
Yeah.
You will have the course details where you can access your calendar of that particular subject. So in the left top, left bottom, there will be an add to calendar. So add that. Keep adding for all the 4 subjects. So all will come together in one calendar sheet.
But I didn't get it. Like computational thinking, it doesn't show me about. I go to week 0 and I go to about the course, and it like notes. It is not visible
No, did you
in there.
access the calendar?
Hmm?
Did you go to the calendar? Week
No, I
0,
go to direct official site.
course
I don't.
calendar. There is something called course calendar in communication and calendar.
Wait,
Week
wait.
0,
Where I
there is
can get
something called important
Uh,
instructions and links.
yeah,
about the course instru
communication and calendar.
Uh,
It's a, like a odd, like it's a book link there, and
no, no,
book
it is an
link there.
announcement group is first, next is course calendar.
I didn't get it.
You have to add for each subject
Week
differently.
Yeah, yeah.
week zero में
I individually adding. I go for individual. Go in city subject in my course. Then I go to course introduction and about the course. Like it will be not
Week
vis. It has
zero.
not visible
No,
No,
to
no,
me.
not
under
only
week
zero.
0, do you
Week
have
zero.
important instructions and links under week 0? Are you able to see that under week 0 itself in the dashboard?
No, it is about the course grading policy, introductory video, common data set.
No, no,
No,
I
no.
don't know about CT. Like CT, there might be something week 0 or something, right? There you can
Yeah,
get
there
all the
is
information.
something called week 0. I am seeing and telling you this.
Okay, week 0 important document and resources.
Yeah, yeah.
Important instructions
yeah,
and links, click that. In the
Mm-hmm.
side, you're able to see how to access dashboard or niche communication and calendar.
number of
Course
sheets.
calendar.
Then you see course calendar.
Yeah, TSS. Yeah, yeah. Thanks a lot. Yeah,
So
thanks a
you're
lot.
able to open course calendar.
Mm.
Now see your left bottom corner. You say add to Google Calendar in blue color. Click that. Do that for all the 4 subjects. You will be able to see the collaborative calendar.
Yeah, yeah, yeah. Thank you
All
very
the
much
best. Yeah, all
for
the best.
guiding me. Yeah.
Okay, so I hope we are done,
Sir,
right?
no, no, one doubt, sir. One doubt in power set. Like, sir, in power set, sir, power